Ruby on Rails is a popular open-source web development framework. It allows developers to quickly build websites that use back-end databases. It takes much of the pain out of adding new features. You can develop faster because it makes great use of best practices, object-oriented programming, and sensible default configurations. This course will explain the underlying concepts of the Ruby on Rails framework. We will walk through its central components step by step so that you can understand how they work together. We will learn how to handle web requests and to work with database data. We'll apply what we learn towards the initial development of a content management system, which is a common real-world project. My name is Kevin Skoglund. I've been using Ruby on Rails since 2006, starting with the very first version, and I run a web development company that has built dozens of real-world Ruby on Rails applications for our clients. I've tried many web development frameworks, and Ruby on Rails is by far my favorite. I'm excited for you to learn how Ruby on Rails can speed up and improve the development of full-featured web applications. This course includes exercise files. Once we start working with the database, beginning in Chapter 5, you may want to sync up your data so that it matches what's shown in the video. I'll demonstrate. First, make sure that you have a database created and a user set up to access it. After moving the exercise files to the place where you want them, go to the command line and navigate to the root of the Rails project. Once you're there, you can run the command rails /OTL:import. The script will walk you through the steps. You can see it provides you lots of information about what it's going to do and ask you if you want to proceed because it will wipe out any database data that you already have in place. So I'm going to say, yes, I do want to proceed. And then it will prompt me through a series of questions. Every time you can hit return if you want to just accept the default setting. I'm going to accept the default for all of those. The import file path is going to be inside the directory, inside DB, and that's where you'll find the SQL file that it's importing. So I'll accept that as well. And then it wants my password. That's my password I used for the Rails user in this case to connect to the database. Once it says import complete, both my files and my database should be in the correct state. Importing can also be useful if you decide to experiment on your own and then want to stop and get your data back in sync with mine. I want to start by introducing you to Ruby on Rails. Ruby on Rails is made up of two parts, Ruby and Rails, and it's going to be important to understand the difference and to keep them straight in your head. Ruby is an object-oriented programming language that was created in 1995 by Yukihiro Matsumoto, who often goes by the nickname Mats. Ruby can be used for many purposes, not just for web applications. It's a general programming language. If you want to learn more about Ruby, the course library includes several courses, starting with Ruby Essential Training, that will strengthen your understanding of the fundamentals of the Ruby programming language. Ruby is the foundation on which Ruby on Rails is built. Personally, Ruby is the part I like the most about Ruby on Rails, because the Ruby language is a pleasure to work with. It's object-oriented, it's easily readable, and it has an unsurprising syntax and behavior. It's easy to write code, and it avoids some of the headaches in other languages, such as carefully indenting lines or ending every line with a semicolon. We don't have to do that in Ruby. Ruby on Rails, on the other hand, is an open-source web application framework, which is written in the Ruby programming language. It was created in 2003 by David Heinemeier Hansson, who the community often refers to as simply DHH. Rails was created as the foundation for the Basecamp application and then released as open source software for anyone to use in 2004. Since then, it's grown into a popular, active open source project with hundreds of contributors who submit new features, find bugs, and make speed improvements. Ruby on Rails version 6 was released in August of 2019. There are very few breaking changes between version 6 and older versions. It's mostly new features and improvements. So even though we're going to be working with version 6 in this course, a lot of what we're going to learn is going to work the same way in versions 5 and even version 4. Now, Ruby is a programming language. Rails is a web framework. Framework might be a new word to you. A framework is a set of code libraries and data structures that provide generic functionality that can be used, overwritten, or further specialized. Now you may wonder, how is a framework different from a simple code library? Well, libraries typically provide functionality that you can call upon, but they don't do anything until they're called. A framework plays a much more active role. It provides more structure, dictates the program's flow control, and has a lot of default behaviors built in.
Ruby on Rails is not the only web framework that's available. There are frameworks in other languages, such as Java, PHP, Perl, Python, and JavaScript. But Ruby on Rails has become one of the most popular web frameworks. Ruby on Rails, like most frameworks, follows a basic software design principle of don't repeat yourself, or DRY for short. The idea is that every piece of information should be expressed in just one place, and then you can refer to it from other places if you need to use it more than once. Dry code is easier to maintain because duplication can lead to inconsistency, or it can make your code unclear and make it harder to maintain and update. Rails is built on this principle of don't repeat yourself, and it's going to encourage us to follow this principle in our code as well. And that's good because it's considered a best practice. The Ruby on Rails framework also follows another principle of convention over configuration. The code is pre-configured to use default options, which are going to fit the most common usages. And this is going to speed up development and give us less code that we have to maintain. Most of the time, we can just use the default settings, and then we only need to add code when we have use cases that are different from those. The defaults also follow best practices of web application development. So best practices will be built in and improve our end product. Rails is very opinionated about what those best practices are. Most of the time, they're not controversial, but every now and then you may disagree with one of its default choices. But that's okay. That's why you can override the defaults whenever you'd like. The Rails framework also has many default features built in, especially web security features. Many of them happen automatically, and you may not even notice them. Other features are not automatic, but are available if you ever decide that you need them. The Rails framework can pay big dividends as your web application matures and grows. The Ruby on Rails framework uses an MVC architecture. It's a fundamental part of how the framework is structured, and it's designed to help us to not repeat ourselves. MVC is a fundamental aspect of Rails, and it's important to understand it right from the start. M, V, and C. The M stands for model, the V stands for view, and the C stands for controller. The model refers to the data objects that we use. It's the object-oriented approach to design. Many things can be objects in our models, but the data in our database will be the most common type of object that we'll put there. The view is the presentation layer. It's what the user sees and interacts with, the web pages, the HTML, the CSS, and the JavaScript. The controller processes and responds to user events, such as clicking on links and submitting forms. The controller will make decisions based on the request and then control what happens in response. It controls the interaction with our models and our views. Let's take a look at a couple of diagrams that I think will make it clearer. First, let's look at the basic web architecture. We've got a browser that interacts with a web page. And of course, there's a web server sitting in between those, but this is a simplified view. This web page might have lots of code that makes decisions and finally outputs something back to the browser. If it's database enabled, then the page can interact with the database and pull information out of the database and return that back to the browser. But the code to do these is in one page, a single long script. In contrast, the MVC web architecture breaks up that single page by function. The browser communicates with the controller, which contains only code involved in making decisions about what should happen based on the browser request. Then if we need to interact with our database, we'll have the controller talk to our model. And in our model, we'll put all the code that's related to our data and to connecting to the database. And then the model will return its results back to the controller. The controller can go back to the model if it needs, and the model can go back to the database, and so on. But finally, when the controller decides it's ready to return a result to the browser, it will send its results to the view, the presentation layer. The view will contain the code related to the HTML, JavaScript, and CSS that should then be returned back to the browser. Essentially, we've just taken that one page, a single web page, and broken it up based on its function into the controller, the model, and the view. Rails is built using this MVC architecture. We want to try to follow this architecture and keep our code in the right places. Decision code should go in the controller, data code should go in the model, and presentation code should go in the view. Rails has name for the code libraries that it uses for these three parts. It calls the controller Action Controller, and the view is Action View. The model is called Active Record, not Action Record, but Active Record. Those names are going to become familiar as we continue working with Rails. Rails also packages together Action Controller and Action View into something called Action Pack. So if you've ever seen the term Action Pack, it's really just the grouping of those two together because they're very closely related. Keep this MVC architecture in mind as we continue to work. We're going to come back and look at this diagram periodically. It's going to help you to understand how Rails structures things and where we should be putting our code. We're going to create our first Ruby on Rails project. The project we're going to create is a simple content management system, or CMS for short. And we're going to be working with this project throughout this training title. This course will assume that you already have Ruby on Rails 6 installed. If you need help with installation, installing and running Ruby on Rails 6 is a course in the library which will help you to get everything installed and configured. Once you have everything installed, you'll also need to decide what database and other software you're going to be using. I'll be using MySQL as a database. The browser I'm going to use is going to be Firefox, and the text editor is going to be Atom. All of these are excellent choices, and as a bonus, all of them are cross-platform compatible so that you can use them on both Mac and Windows. You can feel free to make your own choices, but you may need to make some adjustments as you follow along. The way that we create a new Rails project is from the command line. So you want to start by opening up your command line application. That is going to be Command Prompt on Windows, or you can use the Bash shell, or on Mac OS, you can use the terminal application. Next, let's decide where we want to put our Rails project. Rails doesn't require projects to be in any special directory, but it makes sense to put it somewhere sensible. If you already have a working web directory, put your project there. If not, you can create a directory for all of your projects. You can see that from the command line, I'm inside my main user directory. If I type ls, it'll give me a listing of the files and folders that are in there. You can see that I have one called sites, and that's the one that I'm going to be using. If you're on Windows, you could put it inside your My Documents folder or in a www subfolder inside of that. But don't put it at the root of the hard drive or in the program files directory because Windows has security settings for those directories that may get in your way. Once I've decided what directory I'm going to use, I'm going to navigate in there using cd, and then I'll type the name of the directory, sites. I can type ls space -la this time, and I'll get a differently formatted list of the files and folders that are in there. On Windows, you can use dir. So this is where my Rails application is going to live. At the moment, I don't have any other projects inside mine. Once I've navigated to the directory where I want my project to live, then I can use Rails to create the skeleton of the project. I'm going to clear my screen so it'll just be a little clearer. I'm going to type Rails space and then new and then space followed by the name of my project. And I'm going to call this one simple_CMS. And if you want to follow along with me, you should as well. So simple CMS is going to be the project. And before I hit return, I'm also going to put a -d MySQL option that says create a new project and configure it to use the MySQL database. In the installation course, I show you how to get things set up for MySQL and to get the MySQL gem installed that you need to communicate with it. You don't have to provide this option, but it just makes sure that the project is pre-configured for the database of my choice. So I'll hit return. You'll see that it creates a whole lot of files. And at the end, you'll see that it does something called bundle install. What it's doing is it's going out to retrieve all of the software that it needs and installing it so that we can make use of it. It'll take a few moments while it installs everything. Once it's done installing, I'll type ls and you'll see that it created a directory called simple CMS. If I type cd to go inside that directory, I'll now be inside my Rails project. We call this the root of the project. I'll type ls space -la this time, or dir on Windows, and you'll get a listing of all of the files and directories that are inside that project. We can also view it from the graphical user interface of the operating system as well. If I go inside the sites directory, you'll see here's simple CMS, and inside there are all the files and directories related to my project. Now, if you throw this folder away, you will throw away your entire Rails project. It doesn't create anything that's not in this folder. Everything is self-contained right here. Now that we've successfully created our Rails project, in the next movie, let's understand how the project is structured. In this movie, we'll learn about the basic file structure of a Ruby on Rails project by looking at the project that we just created in the previous movie. There are a number of different ways that we can open up this project so that we can examine it. I'm going to open it in the text editor that we're going to be using. We could do that a few ways as well. We could go to the graphical user interface and drag it on top of the text editor or something like that. But if we're in the command line and we're already navigated to the root of our Rails project, and if we're using the Atom text editor, then we can just type Atom on the command line with a space followed by a period. The period is shorthand for the current directory. So it says Atom text editor should open up the current directory. When I do that, then the Atom text editor opens up and we have two columns. On the left are all the files and folders we're going to be working with, and on the right is where we will actually do our coding. Before we look at these more closely, I want to make a couple of useful changes to the Atom text editor. I'm going to go to Atom Preferences,
And under packages, I can search for tree and it'll pop up for the tree view package. That's going to determine how those things look over here in that far left column. I'll choose settings and I'm going to change a couple of settings. The first is sort folders before files. I don't want to have the folders first. I want to have them all in alphabetical order. So I'm going to take that away. And I'm also going to tell it to hide any files that my version control system has said to hide or anything that's specified as an ignored name. That'll just take away a little more of the clutter, things that I don't care about seeing. Okay, so now that we've done that, we have a smaller list and it's easier to look at the things we want to see. The main directory we want to notice is this app directory. Let's open that up. Inside the app directory is where most of your Ruby on Rails project code will live. You're going to spend 95% of your time in this directory and its subdirectories. There are three main subdirectories I want to call your attention to: controllers, models, and views. Remember we said Rails uses an MVC framework? Well, those are the three parts of that: the models, the views, and the controllers. So we're going to put our code related to each of those parts into those different folders. The other one that will get used quite a bit is helpers. Helpers is a place for writing code to help you with your views. Even though it's just called helpers, you should think of them as being view helpers. Next, notice that we have a folder here called assets that inside has a place for images and style sheets, and one down here for JavaScript. Now, JavaScript used to be included in the assets directory prior to Rails version 6. This is one of the biggest changes in Rails 6 is that JavaScript is handled a little differently. So it's been pulled out of the assets directory and been given its own directory inside app. Now, some of the other folders like channels, jobs, and mailers, those are all going to be more advanced features that we're not going to be using yet, but they're already places so that our code can stay well organized. Besides the app directory, we should also take notice of the config directory. This is where we're going to do all of the configuration for our application, including telling it how it should connect to our database. Below the config folder, you'll see we have something called DB. That's where Rails will store its database-related files. The main thing that's going to go here is something called database migrations. They're going to control the changes that we want to make to the database. If we want to add a table or add columns to the database, that code would go here. And then there's this public directory down here. Public is a little bit of a special folder. Notice that it contains some of the basic kinds of files that we would expect to have any website to have, like a favicon and a robots.txt file, as well as some 404 and 500 pages. Anything that goes in the public folder, you should assume the public has access to. Ruby on Rails is designed that way. Anything that goes in the public folder is going to be public. Now, obviously, a lot more can be public besides what's in the folder because we're going to be displaying code and results from our app. But if you were to just, let's say, drop an image file into the public folder, the public would be able to see it. We skipped over the log folder. That's where you're going to find activity and error logs. The gem file up here is also an important one because it's going to specify which Ruby gems should be loaded into our project. We can click on that now and get an idea of the different Ruby gems that our project is already using. Then there's a number of other folders like bin, lib, and vendor. And these are places where you can put other code libraries and command line programs. For the most part, you won't need to use them. And I think you'll find that most code libraries are now packaged up as Ruby gems and used that way. But we do have places where we can put it if we need to. A lot of the other files and folders that we see, like rakefile and storage and temp, those are things that are used by Ruby on Rails to do its job and not something we're going to need to worry about. For the most part, we're going to be focused on the app directory, and every now and then you'll need to come to the config directory, to the gem file, or the DB directory to make changes to support what you're doing in your code. In this movie, we're going to learn how to configure our new Ruby on Rails project. As you would expect, most of the configurations we're going to do are going to belong in the config directory. Now you may be wondering where to put things in this config directory. One of the primary files is application.rb, but you're not going to add code to this most of the time. And you'll see that if you read the file, you'll see there's a note here that says that the settings in config environments take precedence over anything that's in this file, and application configuration can go into the config initializers directory. And in fact, that's where you're usually going to put your changes. So application.rb will look in those places, and it's better to put your code there. Inside initializers, you can see there's already a number of different initializers. This is where you would add code that would run right at boot so that things are enabled or set up the way that you like them. In truth, you don't end up actually using it all that often. For example, inflections is a place where you can change the way that Ruby on Rails pluralizes some words. It's just not something that you use that often. Environments, however, is useful to look at. Notice that there's 3 different environments in here. There's the development environment. That's the work that we're doing on our local machine as we're building our application. There's the production environment. That's when we deploy it on a server for the rest of the world to use. And then there's a test environment. That's for when we're writing tests that will programmatically test our code to make sure it's working. Those tests will live down here in this test directory at the root of the application. For now, we're really going to be concerned about the development environment. So let's click on that. And you'll see there's a number of different settings already in here. These are sensible defaults. You can change them to be something else if you want, and you can add other configurations in here as well. All of these default configurations are going to be great for us to start with. We don't need to make any changes, but I want you to see where they go. However, we do need to configure our database. Database.yml is right here. It used to be that Ruby on Rails could boot up without needing a database right at the beginning, and we could wait on creating it. But in more recent versions, Ruby on Rails goes out and checks to make sure that the database is there and configured before it even starts up. So we do need to go ahead and create it and get it set up. Notice that in the configuration, there's a default configuration here, which is then being inherited right here for the development environment and the test environment, but with a couple of changes. It's changing the name of database to add to the default configuration. So the default is all fine, except that we're going to have to set a username and a password, and then the database right here. Now notice the convention it's using for naming this. It's the name of my project and then underscore development. And then there's another one for the name of my project underscore test. And if we scroll down, there's one for production as well, the name of the project underscore production. You can use something else, but this is the convention. So we're going to try to stick with it. Okay, so you probably don't have this database set up yet. So let's do that. I'm going to walk you through the steps, but I just want to show them to you first. The first thing is to make sure that you create the database in MySQL. You can get a list of the databases to see what's there, and then you can create the database that you want. You'd swap in your own name in place of DB_name. Once you've created the database, the next step is to make sure that you have a MySQL user. So you can look at the list of users that are there, and if the user doesn't already exist, you can create a new user and give that user a password. And then once you've done that, the third step is to grant privileges for that user to use the database. So you can look at the existing grants for the user if there's any question about whether they have access or not, but then you want to grant all privileges on the database name that you've created, followed by a period and an asterisk to say all tables on that database. Grant those privileges to the username that you've created, and then at localhost. You see at localhost over and over again. We're granting it only for users from our local computer, not someone who comes from another IP address. All right, let's walk through these together. So I'm going to go over to my command line, and I'm going to log into MySQL. I'm going to log in with my root user. I'm going to tell it that I want to use a password. Now I set this up during the installation and put in my password here. Now I'm logged in. We can do show databases to see the databases that are there, and I don't have the database I need. So the next thing I'll do is I will create database, and the database is going to be called simple_CMS. That's the name of my project, _development. And then a semicolon at the end, and now it'll create the database. I can use the up arrow to go up to show databases, and now you can see the database is being created. Now you could go ahead and create the test database as well if you want to, because if we were writing tests, we would be running those on our local development machine. We would just want to keep the databases distinct so that our data that we're using for development doesn't get wiped out by some of the tests that we run. But it's not necessary in order to get things up and running. So we're just going to create one for now. Now that I have my databases, I'm just going to clear my screen, and let's check out the user. Select host, user from mysql.user, and you'll see the users that are there. Now, I already created Rails user during the setup, and if you followed along with me, you probably did as well. If you didn't, then you'll want to follow along and create that user. Create user, and then in single quotes, Rails user, or whatever name you want to give it, at, and then in single quotes, localhost, specifying that's from my local machine only, and then identified by, and then you'll put in whatever your password is. Now, the one that I used was secret password, but you should choose something stronger than that. All right, now I don't need to do that step because I've already created the user. So now I just need to grant the user privileges to use this new database. Now, I don't need to check and see if the privileges have been granted because the database is brand new. So obviously I haven't done that yet. So I'll just grant all privileges. Make sure you spell privileges right. On, and then the name of the database, simple CMS development, and then a period and an asterisk to say all tables on this should get these privileges. And then to Rails_user or whatever username you used at localhost, and then a semicolon at the end. Now that user has privileges to use my new database. So I can exit out of MySQL. We can jump back over to our Ruby on Rails project, and we can just change this. Instead of using username root, which is not ideal, we'd rather not use root. Let's use Rails user, and the password will be whatever password you used. Secret password is what I chose. Once you're done with that, just make sure you save the file, and then you can close it. Now we've set up our database and configured our project to use it. Now that we have our project created and configured, we're ready to learn how to access it from a web browser. The first step to being able to access your project is you need to go to the command line and navigate to the root of the project. From there, we can type a command that'll tell Ruby on Rails to launch a web server that we need to make our project available. The command is Rails space server, or Rails space S for short. It'll become second nature because anytime we want to look at our project and try it out, we're going to issue this command in the command line. When we're done using the web server, we can use Control-C to stop it again. While the web server is running, we can contact it from a browser. And we do that with a special URL, http://localhost:3000. Localhost is just an alias for your local computer. If for any reason it doesn't work, you can also try 127.0.0.1. They should be synonymous. The :3000 at the end is important because our web server is going to be serving files on a special port, and that's port 3000. So this is just telling it to go to our local computer to look at port 3000 for a web server that's serving up files. Let's try it out. So the first step is to go to your command line. The second step is to make sure that you're in the root of your Ruby on Rails project. And from there, you type Rails space server, or just Rails space S for short. You can see that then boots up Puma is the name of the web server that's built in. It tells us that it's launching our Rails application in development mode. It also tells us down here that the environment we're using is development, and it tells us where it's listening for browser connections. It also says Control-C anytime we stop, but until we hit Control-C, it's going to keep running. So our web server is now running, and it's waiting for connections from a browser. So let's go over to our browser, and let's try making a connection. I'll open up Firefox, and we'll type in localhost:3000. You don't have to type the HTTP, but you can. And you'll notice it comes up and says, yay, you're on Rails. This is the default page that's built in to let us know that we've got everything working correctly. And you know that the web server returned that page because you actually can see some feedback happening in this window here as it renders results back to the browser. Now, this is just the default page. Obviously, we want to change it so it's going to use our custom code instead of the default code. But the basic process of accessing your project from a browser is always going to be the same. We will begin customizing our Rails application by learning how to generate a controller and a view. Remember the MVC diagram that we saw earlier? The browser contacts the controller makes choices and decides how to proceed. It may contact the model, which may be attached to a database, to retrieve data, and once it's assembled everything it needs, then it's going to go to the view to render a template to return back to the browser. I want you to notice that the right part of that diagram, the model and the database, is optional. Some requests may not use them. The browser can contact the controller, which then can immediately render a view back to the browser. That left-hand triangle, though, is essential, and it must happen with each request. That's where we're going to focus for now, and we'll learn to work with models later. Let's see how we can create the controller and view. We're going to generate a controller and view using the Rails command again, but this time with generate, or you can use G for short. If I just type Rails generate by itself and hit return, Rails will come up and tell me the different types of things that it knows how to generate. You can see here it can generate a controller, a helper, a mailer, a model, and so on. What we want right now, of course, is the controller. So I'm going to clear my screen. I'll hit the up arrow. We want Rails generate controller. And if I hit return again, it'll give us another help page telling us that we didn't quite give it enough information. It's going to help us to create a new controller.
It gives us some options here that we can use, but I want you to notice here that says we're going to pass in the controller name, either camel cased or underscored, and a list of views as arguments. So that's what we want to do here. I'll clear the screen again, and this time Rails generate controller, and the controller name will be next. I'm going to call it the demo controller to begin with. So DEMO, you can make it capitalized or you can do it lowercase. It doesn't matter. It'll still give it the right name. And then a space and a list of the views that we want it to create. I'm going to just create one that's called index. So this will create a controller called demo and a view called index. Let's hit return. It'll then tell us what files that it creates. We can go take a look at those files inside our project. Inside the app directory, if we look inside controllers, you'll see there's now a controller called democontroller.rb. Demo controller is a Ruby class, and it's inheriting from another controller called application controller, which is up here. Typically, all of your controllers inherit from application controller, and that way you can put code that's common to all of them in that one place, and they'll inherit that behavior. Now you can see that it also added a method inside this class. It's a Ruby method called index. If you've never worked with methods before, it's like a function. Now, when it's inside a controller, we also have another name for it. We call it an action. So this is an action that the controller can perform. We're not going to worry about that action for now, but I am going to just add a line right up here that says layout space false. We haven't learned about layouts yet, so I just don't want us to get bogged down in them. But essentially a layout is something that you can use with your views. We're going to turn off that behavior to begin with. Okay, so we have our demo controller that created. If we take a look inside views, you'll see that it created a new folder here also called demo. Open that up and you'll see that there's a file in there called index.html.erb. That is our view template. And you see it has a little bit of HTML inside of it. Let's change it to something different. Let's change it to just say hello world. And I'll just get rid of this here. And you can put anything you want. This is a place where you can put HTML. It's the content that we're going to return back to the browser whenever this view is rendered. That's the word we use. We render the view back to the browser. Now, those are the two main things that we knew we were creating. If we go back here and you take a look, you'll see that it did create a few other things. The one that I want to call your attention to is this route here. We also want to notice that down here inside the config directory, there's a file called routes. And routes tells our application how to direct the requests that it receives. By having a route here that says get demo index, it knows to route requests that come in for demo/index to our demo controller and its index action. We'll talk more about routes a little later on. For now, just make note that these are the three key pieces. We have a route that sends the request to the controller. The controller then has an action that'll do whatever code we want it to do, followed by rendering the view. I also want you to note that these two files that were created and the change to our routes file are something we could have done ourselves. We could have by hand created those two files with that content in it and made the change to the routes file. The generator just helped make it easier for us. But there's nothing special about them. They're just simple files. We can try out our new code by going back to the command line. Let's make sure that we're at the root of our project still, which we are. I'm inside Simple CMS. And from there, I can type Rails S or Rails server. That'll launch that Rails server. Once it says that it's listening, I can go into Firefox and go to localhost 3000. And you'll see I get that temporary page. But if I now add /demo/index after it, it routes it to my new page. This is the basic process that we're going to be using to create web pages inside our Rails application. In this movie, I want to give you a better understanding of how server requests are handled in a Rails application, because there's some subtle but important points to understand. We've already seen a general diagram of the MVC architecture. This shows a simplified version of how Ruby on Rails works. Now let's look at it a little closer. The browser contacts a web server. In development, that's going to be Puma. In production, it might be Nginx or Apache. And then the web server is going to look at the public directory inside your Rails project. You may remember that I told you earlier that the public directory was a little bit special. And that's why we're going to configure our web server so that it looks at that public directory. And when a request comes in from a browser, the web server will look in that public directory to see if it can find a file whose path and name exactly matches what the browser is looking for. And if it does find it, then it will return that file back to the browser and never access the Rails framework at all.
This is handy because it allows us to return static HTML pages, images, style sheets, or JavaScript very quickly. But if the file is not found, then it asks the Rails framework to handle the request. The request first goes to the Rails routing. Routing parses the URL to determine which controller and action to use. Then it calls up the correct action code inside the correct controller, and the controller may call models to gather data before rendering a view, which is then passed back to the web server and back to the browser. The key items to notice are the addition of that public directory and the routing. Let's do a demonstration to illustrate. You can see that I've got the directory with my Rails project open here inside the operating system, and I've got another file here called static.html that's also included in the exercise files that I'm just going to drag into the public directory. Once we do that, let's go take a look at it inside the Atom text editor. So scroll down till you find public. We'll open it up, and you'll see that static.html is just a very simple HTML page. You can create your own, or you can use the one in the exercise files. Now, what I want to show you first is that this page is accessible by the web server. So let's just go over to our command line, and I'm in the root of my project. I'll type Rails S to start the server. Puma will boot up. Now, as soon as it says listening, I can jump over here to Firefox, and let's type in localhost :3000, followed by static.html. And we get back that static page. So that shows you that the web server is looking for this page as the root, right? It's not going anywhere else. Directly, the root of the website is right there at that public directory. And notice also that it didn't give us any output from the Rails application here like it did before. Before, when we hit one of our controllers and actions, we got lots of output letting us know what Rails was doing. It didn't do that. It didn't hit our Rails framework at all. It just returned the page directly. And we can remind ourselves what that looked like if we change this to instead be demo/index, right? We get our hello world page, and you can see now it comes back and it tells us it started this command. This is the routing. And then this is what it ended up doing. It processed it with this controller and index, and then rendered the view back to the browser. Now let's try a little experiment. Let's hide these so they're out of our way. We're back to our project again. Inside the public directory, I'm going to create a new folder. So let's go up here to File, New Folder. I'm going to call it Demo. Let's take that and drop it in the public directory, and let's move static into it. Okay, so now we've got demo static inside the public directory. I can see that in Atom as well. Here it is. And let's go back to our browser. We don't need to restart our web server. It will pick up our changes. So demo index returned our page from the Rails application. Demo static.html now returns back that static file. Demo looks the same in both cases, but in one case it's a folder name, and the other case it's a controller name. Right? When it's first going to the folder, it's looking to see if it can find the exact path to this file. When it can't, then it gives the whole URL over to Rails, and Rails parses it to find out whether there's a controller and an action that matches. I also want to show you that we can actually take away .html in this case, and the web server doesn't care. The web server will still return demo static. The .html is a default that's assumed. So it still returns it even this way. So demo static and demo index look a lot alike. Let's make another change. Let's come back over here, and let's change this file name from being static to being index. So it's demo index.html. Let's come back to our browser, and let's change this to look for demo index. And now, instead of getting our hello world page, we're getting our static page, right? We interfered with its ability to get to the Rails application because there is a static file that matches first. We obviously don't want to leave it that way, so let's just change it back. Now that we've proved that it works, we'll make it to static.html. So one last time, let's open up the terminal, and let's open up Firefox, and let's reload this page. And if you get a cache version, you may have to hold down to make it reload. But once you get a reloaded page, you'll see I get the hello world back, and you'll see that it did hit the Rails application this time. Now, most of the time, you're going to want to put all of your code inside of the application. But it's important to understand how the public directory works and its role in routing requests into the application, and to know that any file that you put there will be served as a static asset without having to go through the Rails application. In this movie, we will learn how Rails routing works. We saw the Rails architecture. If a web server can't find a static file in the public directory that matches the current request, Then it sends the request on to the routing portion of the Rails framework. Rails routing examines the URL to determine which controller and action should be called. It does that using the definitions in the application's routes file. There are several types of route definitions. There's the simple match route, there's the default route, there's the root route, and resourceful routes. We'll discuss the first three now and save the last one until later. The routes file is stored in config/routes.rb. And if you look there now, you'll see an example of a simple match route because it was created when we generated our controller in Vue earlier. It says get, and then inside quotes, demo/index. This is a shorthand. The longer equivalent is to write it out this way. Match, and then the string that we're matching, the thing that should be in the URL to look for, where we should then send that request. That's what the to portion is. And it has demo with a pound or hash sign followed by index. That lets us know that we're mapping this string to the demo controller and the index action. And we're going to do it using a GET request. On the web, most requests are either GET requests or POST request. GET request is typically just a URL that retrieves information, where POST request is usually a form that's submitting information. Now you can see why the shorthand is preferable. It's a lot less typing, but it does mean that the string that we're matching has to be the same as the controller and action. If the to portion is not going to be the same, then we'd have to use the longer version. But that's all there is to a simple match route. The second type of route is the default route. And as we'll see, this is more flexible than the simple match route. Default routes have this basic structure: controller, followed by action, followed by ID. Here's an example. Let's imagine that a request comes into the web server for students/edit/52. The default route would look at that and say, well, that first portion must be the student's controller. The second portion must be the edit action, and the last portion must be an ID of 52. But instead of specifically matching those exact strings to those places, the default route instead uses a pattern to describe it. So the way you add a default route to the routes file would look like this: get, and then controller, and then inside parentheses, action, and then inside parentheses, ID. You could also write it out a slightly longer way using match instead. The symbols for controller, action, and ID have a special meaning. They act like variable names or like regular expression patterns, and they allow us to match any URL that follows this format into its controller, action, and ID. The parentheses are there to indicate that some of those portions are optional. It will match a controller name by itself, a controller and an action, or something that has all three parts. You can use the default route to handle most mapping to your controllers and actions without having to list them out one by one. Usually you want to put it near the end of the routing file so that any simple match routes can be handled as needed, and then the default route becomes a catch-all for anything that wasn't matched earlier. In early versions of Ruby on Rails, this is how all routing was done. Over time, as resourceful routing became more popular, default routes have fallen out of favor. I'll demonstrate how they work, but we won't lean on them heavily. We'll use simple routes until we learn about resourceful routing. The third type of route is the root route, and it only has one purpose: to route a request to the root of the application when no controller or action is specified. You can think of it like the route that sets the home page of your app. Usually you put it at the very top of your routes file, and it looks like this. You just do root and then the string that says where you want to match it to: demo, $index. You can also write out the longer way, which is match nothing. When we're asking for something that's just the root of the website, send it to this location. In this case, the demo controller and the index action using the GET request. This is a route you'll want to define in every single one of your projects. Let's take a look at these in action. So again, it's going to be in our config file, and we're going to scroll down till we found routes.rb, and this is the file where our routes will be listed. They're going to be checked in order going from the top down to the bottom. So we have this initial simple match route that was already created for us. So we already have an example of that. Let's just try the default route. And so for the default route, we're going to use get and then :controller and in parentheses :action, and then also in parentheses /ID. So that gives us the first two examples. Let's look at the third example, which is that root route, which we'll put up at the top. So we're just going to type demo and then # index. And that's it. Now we've got our root route defined. So let's save these. Let's actually just comment out this simple route. We've already seen how that works. I just want to comment it out for a second so that our default route will work instead. Let's go over here and let's fire up our web server from the terminal, Rails S. I'm in the root of my Rails project. As soon as it says that it's listening, I can go to Firefox. And let's just try first going to the root route, which is just localhost :3000. And look at that. It did bring up our page. If we come over here, it says it processed the request for just a /, just the root of the application, and it processed it by demo controller index. The root route sent it to the right place. All right, so now let's try another one. Let's try demo/index. That also worked too. If we come over here, demo index was routed also to demo controller index. That's happening because of that default route that we set. If we also had taken away index and just done demo by itself, it still works. That's because index is an assumed default that it uses in that default route. So if nothing is provided, the action is assumed to be the index action by default. Now, we don't have another controller right now, but if we, let's say, tried students, you can see that we get a routing error, and it comes up and it was trying to match it, and it was trying to send it to the students controller. So it says no route matches students because we don't have any kind of students controller. It gave us back an error. So let's go back to our routes file and let's just take out this comment. So we have our simple route defining that one, and let's comment back out the default route for now. Let's come back over here to the page. And one last time, let's make sure it's working with demo/index. And yes, we're getting it using that simple route now. So that's the basics of routing. The point of routing is to take a string that's in the URL and figure out how to send that to appropriate controller and action inside our Rails application. It's time for your first challenge assignment. And this is an easy one because there's no right or wrong answer. What I want you to do is to experiment with the things that we've learned in this chapter. Generate at least one more controller for yourself. You can either do that using the command line generator that we used before, or you can try creating the file manually yourself and putting it in the controllers folder. And along with your controller, try and create a couple of different views. You can also do that from the command line. Right after the controller name, you can list several different names of views you want created, or you can add those manually yourself by adding an action to the controller and adding a template into the proper folder in the views directory. Try writing several different routes. Try some of the match routes. Try writing them out in the shorthand and the longhand form. Try using the default route. Then add some static files. See how you can name static files so that they might interfere with some of those routes. And notice when the web server is able to serve those static files without going through the Rails routing. There's no correct solution to this challenge. The point is for you to explore and get comfortable using these tools because we're going to build on them in the next chapter. In this chapter, we're going to examine how the controllers and views work and how they allow us to output dynamic content. And we're going to begin by learning how templates are rendered. We've already seen the MVC web architecture diagram a couple of times. And in the last chapter, we talked about the fact that the model and the database are really optional. The parts that are essential to every request and response is that the browser has to send a request to the controller then chooses a view template to send back to the browser. This triangle is what we're going to be focused on in this chapter. There are three essential parts to this request-response loop. The first is that we need to have a route. That route determines how a URL is sent to the correct controller and action. Then we want to have a controller action that will perform whatever code we want to use as a response to it. And then ultimately we need to have a view template that's going to decide what we send back to the browser as a response. In the previous chapter, we created these using a generator, but I told you at the time that you don't have to, you can create them by hand. So let's do that now. So our routes file is going to be in the config directory. And we can see we've already got a route here for demo index. I'm going to add another one, get demo/hello. So now any request that comes in as a URL for demo/hello will be routed to the demo controller and the hello action. Let's save that file. And then let's go to our controllers and find our demo controller, which already exists. And now we need to add an action to it. Def hello. That's going to define the method on the demo controller, which is also known as an action. So now we have an action that can handle it. And there can be all sorts of code that's inside here that does various things. But at the end, we want it to render a template back to the browser. And so that's going to be something we put in the views. Let's save this and go to views. And here's a folder called demo. We're going to open this up and you see there's index.html.erb. You could create a new file here a couple of different ways. There's a file, new file up here, but I can also just control click on it and choose new file. And then it gives me the path already, app/views/demo, hello, and then .html.erb. Don't worry about what those file extensions mean right now. Just go ahead and put them in, .html.erb. We'll hit return. So let's try it out. We've got the 3 essential components. So let's go over here and let's launch our Rails server from the root of our web app. Once it says it's listening, we'll jump over to Firefox and I'll just reload this page first of all. And you see this is the index page. And let's change it to hello. And now it successfully routed demo/hello to the correct controller in action, which rendered then the correct template. It says this is the hello page. Let's go back to our code for a moment. Let's look at the demo controller. So we've talked a little bit about how the route picks the correct controller and action, but how does the controller pick the correct template? It does that using sensible defaults. If it's the demo controller and it is the hello action, then it's probably a template that is in the demo folder called hello.html.erb. That's the default behavior. If we don't specify anything, that's what will always be rendered. And most of the time, you won't need to specify it. You'll just let the default behavior take over. But there are times when you want to render something that's different. So let's talk about how we can choose something else. So as I said, the default is to use the current controller and the current action and take those names and turn them into the folder and the template file in order to find something that matches. But you can also provide the render command inside an action and then choose a different template. Here you can see I've got template and it's pointing to a string that is demo/hello. Now in this case, demo is not the controller, demo is the folder name that we're going to look for in the views, and hello is the name of the template. Don't worry about the .html.erb, it gets assumed. Rails is smart enough to know that it's got to tack on a file extension. Now, I don't know anyone who actually writes render this way because there is a shorter version. So most people write it this way, render and then just the string, telling it which directory and which template you want to render. If the template is in the directory for the current controller, then you don't even have to put the first part in there. You can just simply say render hello, and it'll go find the hello template in the directory that corresponds to the current controller. We can demonstrate this by going back to our code and let's type in render. And this first one, let's do demo/index. And then for the second one, let's do render and let's just do hello. So again, this is just the default behavior. I'm just being explicit about it here instead of letting the defaults kick in. Let's go over here and just prove to ourselves that it works. We'll reload that page first and it worked just fine, and index, and that worked fine as well. Now, just to prove it to ourselves, let's swap them for a moment. Let's do hello and let's do index. So they point at each other. They're rendering something besides their default now. So we come back to demo index and we'll hit return. We get this is the hello page. And when I go to hello, I get this is the index page. They're crisscrossed. Now, again, most times you won't need to do that. Most times you can just let them do their default behavior on their own. So I'm going to comment these out. So now you know how to specify an explicit render. Again, most of the time you won't need it. You'll use the default behavior and the template will just match the controller and the action name. In this movie, we'll learn how to redirect actions from the controller. Controllers can respond to requests by rendering a view, but that's not their only choice. They can also redirect or send the user to a different controller and action. Imagine this scenario. A user requests a web page that's inside a password protected area. The code will check to see if the user's logged in or not before giving them back that template. If they are logged in, then they'll be able to see the page. But if they're not logged in, then we want to redirect them to a login page so they can enter their username and password. We could choose to just render the login template, but that's not quite what we want. We want the URL in the browser to change to the new page, and we want the opportunity to execute more code that's associated with the login page. The two may seem similar, but it's an important difference in practice. A redirect is not unique to Rails. It's part of the HTTP specification that makes the web work. Rails just puts them to good use. When you redirect, what actually happens is that Rails returns a status code to the browser, which looks like this. The location is the new URL we want the browser to try. When browsers receive this response, they automatically make a new request for this new URL. That URL then goes back through the routes and arrives at a different controller action. Note that any code that we executed before the redirect is gone. This is a brand new web request. If we set any variables or retrieved any data from the database, we'll need to set those again or look them up again. Now that you understand what they are, let's learn how to add a redirect. In Rails, we do that with the redirect_to method, and you want to pass in the controller and the action that you want to redirect to. Rails will take this hash and figure out how to turn it into a URL that it can send back to the browser. I want to note that you can also use a different format for writing your hashes. This is perfectly valid Ruby as well. Controller with a colon instead of having :controller followed by that arrow from the equal sign and the greater than together. Either one works. I'm going to be trying to stick with the first one in this tutorial. If you're redirecting to an action that's in the same controller, you don't even need to specify the controller at all. You can just specify the action. The controller will be assumed to be the same by default. Redirect is also not limited to only redirecting to other URLs inside our application. We can redirect anywhere we want. For example, if you pass in a string that starts with HTTP or some other protocol, then Ruby on Rails will assume that it wants you to use that URL as is, and will send that back to the browser and redirect the user to that URL instead. Let's try adding a redirect to our application. Let's just use our hello action as a place to put it. So right underneath here, I'm going to put a redirect to, and the idea would be that there's all sorts of code up here, maybe that's getting executed and things that are happening. But at some point we decide, based on information we've looked at in the cookies or the session or the database or calculations we've made, we decide that we don't want to handle this by rendering a template. We want to redirect the user somewhere else. So we've got redirect to, and then I'll do controller demo. And again, that's optional because I'm in the same controller, and then action, and we're going to redirect to the index action. So how does it know what URL to create from this controller in this action? Well, it does it from the routes file. It goes back to the routes and it figures out how to generate a URL from demo and index in order to turn it into this URL string that it's going to send back to the browser. So let's save it and let's try it out. Now go over here to your web browser. If you can, clear your screen so that we can keep track of the requests as they come in. Let's go back over here and you can see I have demo hello already in my URL bar. So I'm just going to hit return. And you can see that it redirected me. This is the index page. So it sent me to the index page. You can see that the URL changed as well. And if we come over here and we look, we'll see that there's actually two requests that came into our web application. The first was a request for demo hello. And you can see it routed that to the demo controller and the hello action. And then it redirected to this new URL. So it sent that response back to the browser, and the browser immediately made a new request again. So here it is, a request for the root of the website, which it routed to demo controller index, and then it went ahead and rendered that template. So there's two requests there. That's very important to notice. And any calculations we made or data we might have retrieved during this action will not be available here unless we stored it somewhere. Now, if you're wondering why the demo index request ended up being just the root of the website, well, that's because that's one of our routes. If we look at the routes, it went ahead and saw that the root route was also demo index, and it preferred that because it was shorter. It'll try to use the shortest route that it can. So the main things I want you to understand about redirect to is that this is one of the main other options you have to rendering. You either render a template or you redirect somewhere else. The second thing I want you to understand is that it does end up generating a second request. We've seen how controllers can either redirect or render a view template. In this movie, we're going to take a closer look at the view templates. So far, our templates have been composed of only simple HTML, but that's not going to be very dynamic or database driven. It'd be better if we could embed Ruby code into the templates so that we could use dynamic information. To do that, we're going to use ERB. ERB is short for Embedded Ruby. It's a templating system to embed Ruby into our pages. You may remember those letters ERB were part of the template file names that we saw earlier. We had hello.html, .erb. What this means is that the template's name is hello, it's going to be processed with ERB, and the final output format will be HTML. There are other templating systems and you can have other output formats, but this naming scheme is always the same. So the first step in being able to embed Ruby code is to have the correct file name. Once you have that, and you have .erb at the end of the file, it'll be processed with eRuby. And then we just need to use the correct ERB tags to tell Ruby what it should put in the code. There are two ERB tags. The first uses a less than sign and a %, followed by any code that we want to use, and then it's closed with another % and a greater than sign. The second ERB tag is the exact same, but with an equal sign right after that first percentage. The difference between them is the first one executes Ruby code. The second one executes Ruby code and outputs the result into the template. The first one doesn't actually output anything into the template. The equal sign is telling it that this also should be output. It's an important difference. If you're familiar with using Ruby before, you may be tempted to try and use puts or print or something like that. Those don't apply here. This is not Ruby we're working with, it's the ERB template, and we have to use its conventions. So let's start by adding some ERB into our hello template. I'm going to just comment out this redirect because we don't want it to redirect anymore. We want it to render the hello.html template. We'll leave this as the hello page at the top, but let's skip down and let's use our ERB tags. And let's start with just doing 1 + 1. Very simple Ruby code inside those ERB tags. And let's see what we get. Let's save the file. Let's go over here and let's launch our web server. And once it comes up and tells us that it's listening, we'll jump over here to Firefox and let's load up /demo/hello. This is the hello page, but we didn't get any output. You know why that is? Well, we didn't tell it to. We used the ERB tags that calculated but did not output. So this did in fact add 1 + 1, and then it did nothing with that at all. If we instead put the equal sign there, let's save the template, come back to the page, and let's reload it. Now you can see that it outputted 2. So that's a very important difference. Now you're going to use both. For example, let's do a BR tag here, and then let's use the ones without the equal sign, and let's set target equal to world. And then let's do another one. It's going to use the equal sign, and it's going to say in double quotes, has to be double quotes, hello, and then we'll interpolate. That's what this is called when we do this, where we have a pound sign or hash sign followed by the curly braces, and then a variable name inside. And then let's put an exclamation point at the end. And let's save it. Let's go over here and reload the page. And you'll see now it output hello world, right? So it's very common that we'll do things like set variables inside the tags here. But when we actually are ready to do the output into the template, we'll use the equal sign. Let me just do one more illustration here. Let's do another BR tag, and let's do a typical Ruby expression might be 3 times do in. That's going to be a loop. And then we'll close our tags. And then inside there, you might be tempted to do some basic Ruby like puts in, right? That's going to output some numbers as it loops through each time. Let's save it. Let's see what it does. We'll come back here and reload. And it doesn't output anything at all, right? Puts didn't do it. Even though puts normally does output, what it did do is it actually put it in the console. It's over here so we can see it because it output it to standard out, and that's what's considered standard out. That's not what we wanted. What we wanted instead was to output it to the page. So it's be more common to do something like this. Just give me a second to make these changes. And then let's say we're gonna have some paragraph tags, and then we'll close our paragraph tag at the end. So here you see I've got some basic Ruby code that starts my loop 3 times do in. Then I've got some HTML. Then I'm doing an output of the number, and then I'm ending my loop here. So it's perfectly acceptable to jump back and forth between the different parts of Ruby code, HTML, and Ruby code that you want to output. Let's save it. Let's go back to our page and let's reload it. And that's what we wanted, 0, 1, and 2. So you're going to surround any Ruby code that you want to be processed by the page using these ERB tags. And if you want it to output something to the page, then you need to use the one that has the equal sign too. In this movie, we'll learn to use instance variables to allow the controller to provide data to the template. Let's go back to the MVC diagram again. One of the primary responsibilities of the controller is going to be to gather data from the models and from the database. Once it's done that, it needs to make that data available to the view template so it can be presented back to the browser. A good way to think of this relationship is to imagine a rock concert. There's a guitar tech who tunes all the guitars and sets them up on stage ahead of time. There may be different guitars for different songs. During the concert, the guitarist just has to walk over and pick up the guitar and play. The guitar tech took care of everything else ahead of time to make it easy for the guitarist to put on a good show. That is similar to the relationship between the controller and the view. The controller sets everything up ahead of time so that the view can just focus on the presentation of the data. The setup has already been taken care of. To pass data from the controller to the view, we're going to use instance variables. Remember that in Ruby, you can tell the difference between a regular variable and an instance variable by the @ sign that's at the beginning. An instance variable has scope so that it applies throughout the instance of a Ruby object. In this case, the object will be an instance of the controller class. Once we set an instance variable, you can access that value from other methods that are called on that same object. When Ruby renders a template, it gathers up all of those instance variables that have been set and makes them available to the template. So a regular variable will not be available for use in your templates, but any instance variables will be. It makes it easy to pass data to your views. To see this, let's start by going to Demo Controller, and in the hello action that we created, let's add a variable. So I'm going to have array equals, and then I'll just do 1, 2, 3, 4, 5. So it's an array of values, numbers 1 through 5. This is just a simple regular variable in Ruby. It's not an instance variable. I will not have access to it in my template. So in the hello template, I can try and call array all day and I won't get any values back from it. It'll say that it's not been set. Instead, if I put an @ symbol in front of it, now it becomes an instance variable. Notice that this is a Ruby class, demo controller. So this is an instance variable inside this class. And if I had other methods maybe that were being called, they would have access to this variable anywhere inside this class. But most importantly, I now have access to it in my template. So let's save that file. Let's come over to hello.html.erb. And in place of 3 times do, let's just change this to be @array.each. So that's going to go through each item in the array, and it's going to use that instance variable @array, and it'll be available for us to use. Let's save it. Let's fire up our web server, and let's try it out. As soon as it says it's listening, we'll load up the demo hello page, and you'll see that now it has 1, 2, 3, 4, and 5. It's a pretty simple mechanism for getting data into our views, but it's very powerful. Imagine instead that the demo controller had gone to the database and had retrieved a list of customers, maybe 100 customers long from the database. We could put them in an array and we can make them available for our template so that we could list all 100 of our customers. Instance variables are the key to making that happen. Now, even though there's a cozy relationship between the controller and the view, it's important to note that the communication between them is only one way. The controller sets up code for the view to use, but the view can't go back to the controller for more information. Everything needs to be set up ahead of time. We've seen how a single web page works, and to see those pages, we've been typing the URLs into the browser. In this movie, we'll learn to create links between pages. This is a basic HTML link. The text is click me, and the link target is /demo/index. This is a perfectly valid link to use in Ruby on Rails. The important part is that link target. It just has to be a text string that matches one of our routes. When this link is clicked, the browser will then send a request using that string to the web server, and the request will be parsed by the routes and then sent to the correct controller in action. While simple HTML links work, they're uncommon to see in Rails applications. The reason is because there's a helper method that helps to make link creation easier, link_to. It will be especially useful when links don't just have static text in them, but need to be more complex. The first argument to link to is the text of the link. For example, click here. The second argument will be the target, that is the URL that the link will call when clicked. The output from this method into the template will be HTML, almost exactly like the HTML link we just saw. Rails just helps you to create it. The target can be several things. You can include a simple string, or you can provide a hash that lists the controller and the action, and Rails will convert that into a string for you. As we saw with the redirects, Rails uses our route file to figure out how to create the right string. And as with our redirects, we only need to specify the controller if it's different from the current controller. If you leave it out, then Rails will assume that you want to use the current controller again. Let's add a link to our application. I already have my template here for index.html.erb open, so let's add one here. I'm just going to drop down a line, and let's add in first just a basic HTML link. href equals, and then in double quotes I'll put demo/hello, and then let's close that tag. We'll put the text for it inside, hello page 1, and we'll close the tag, and let's put a BR at the end. Now let's write a Rails link using the link to helper. I need to have the ERB tags using output because I do want to output the results to the template, link to, and then my first argument is going to be the text. I'll put in hello page 2. And then the second argument, I'm going to use the hash format to say action is going to be equal to hello. Now I don't have to specify the controller because I'm already using the demo controller. I can take advantage of that and leave that out. If I was going to use a different controller, then I'd need to specify it. So now that we have both of those, let's save our page. Let's fire up our web server if we don't already have it running. And let's go back over here to the browser. And I'm going to be loading up demo. And then as soon as it says it's listening, I'll type in index. And there you go. This is the index page. And I have two links, hello page 1 and hello page 2. Let's click on hello page 1. It goes to the hello page. Let's go back. Hello page 2 also goes to the same page. Go back one last time. In Firefox, under Tools, I can choose Web Developer, and I can choose View Page Source. We can actually take a look at those links, and you can see that the output to the template is exactly the same. It doesn't matter that I used the Ruby on Rails helper to create the output. The ultimate output that goes on the page that's sent back to the browser is just basic HTML. Let's close the source up. Let's go back into our project, and let's go to hello.html.erb, and down here, let's add a BR tag, and we'll follow that with another link. This one will be %equals link to, and this one will just have be index page. And the action is going to be index. Make sure that we close our ERB tags, save it. Let's go back. And now when we click hello page 1, now I'm on the hello page. Here's index page. When I click it, I go back to the other page. Using the link to helper makes it easy for us to add links to our templates so that users can move around inside our web application. In the previous movie, we learned to create links and to specify the two most important parts for the URL, the controller and the action. But what if we want to send other parameters in the URL string? Perhaps we're browsing a multi-page list and we only want to view page 5. In this movie, we'll learn how to work with these parameters in Rails. You'll recall that in HTML, the URL parameters are the portion of the URL to the right of the question mark. In this example, page equals 3 and name equals Kevin. There's an equal sign between each of the parameters name and value, and there are ampersands in between each pair. If you use the link to method and pass in a hash of values to create your link, then you can just list the parameters inside the hash. This makes managing a complex list of parameters much easier. Rails will take care of turning that hash into a URL string. When the link is clicked, the request will be sent to Rails, and in addition to routing the controller in action, Rails will also gather up all of the parameters so that you can have easy access to them. Rails puts those parameters into a special object that you can access using params. Rails will put all get and post values into that same object. Get values are parameters from the URL, post values are submitted by a web form. In some languages, like PHP, these are kept separate, but in Rails, they're merged together, so there's only one place to go look for them. You can think of this params object as a Ruby hash, even though it has some special features. One of those special features is that you can retrieve values out of the hash using either a symbol or a string. With a standard Ruby hash, each of these would return a different value, but in Rails, they can be used interchangeably, which is handy. Let's try writing a link that has some parameters in it. Let's go to index.html.erb, and I'm just going to add a BR tag here. And then underneath it, let's copy this link from up here, save ourselves some typing,
Let's change it hello with parameters. And in addition to the action being hello, let's add another one. Let's add :page and then 5. And then let's add another one for ID and point that to 20. I'll open my window a little bigger so we can see those all on one line. Now let's save that page. Let's make sure that our web browser is still running. Mine is. Let's come back over here and reload our page. And now we see we have a new link, hello with parameters. And when I roll over it, you can see at the bottom of the browser window that it tells you what URL it's going to go to. Let's go ahead and click it, and you'll see that it takes me there. Demo/hello, and then question mark, ID equals 20, and page equals 5. We didn't have to write all of these values out. We can just simply provide it as a hash. Now I do want to call your attention to the fact that ID is on the right side of the question mark here as a regular parameter. Most of the time, ID has a special status. If we come back over here and we look at our routes file, you'll see that in the default route, I'll just uncomment it for a moment, you'll see that ID is listed here. ID isn't listed here in demo/hello, but if it was, like it is here, then it would be included in the URL. Each one of these is reserving a spot for the controller, for the action, and the ID. And ID is often given this privileged place on the left side as part of the URL string and not as a parameter. If you want to try that out real quick, let's just comment out the hello. Let's save this. We'll just go back here, hit the back button. We'll reload this page. And now when I click hello with parameters, you can see it says hello/20. It's no longer on the right side of the question mark. It's now on the left side. So just be aware of that sometimes ID has this privileged position. So now that we know how to write a URL with parameters, let's see how we read it. Let's go into the controller. Most often you're going to access these values in the controller. Remember, that's what sets everything up that the Vue template needs. So we often want to check the parameters, maybe to go to the database and retrieve some data or do some other calculations, and then provide results to the Vue based on that. But the Vue also can access that special params method, and we'll see that in a moment. For now, let's just go under array here, and let's add ID equals. Let's do params, and then let's do this one with single quotes around it. And then underneath it, we can write page equals params, and we're going to pull out the page value using a symbol with that colon syntax. Okay, so now I'm setting both of those equal to instance variables, and we know that once it's an instance variable, we have access to it in the Vue. So let's jump over to our hello template, and let's take a look at those. I just add a BR tag here to separate this, and let's do ID colon, and then the first one, let's do @ID, and then we'll put a BR tag at the end. Then let's do another version. And I just want to show you that you do have access to params here as well. So we'll get the value of ID there and output it a second time. And then let's do page. And we're going to ask for @page instance variable. And I'll put a BR tag at the end of that. All right, let's save it. Let's go back to our browser. I'll hit the back button. Let's reload our index page. Hello with parameters. Here's the parameters. It read those, ID equals 20, page equals 5. And we did have access to params from the Vue as well as from the controller. Either one of those works. And it didn't matter whether we used a symbol or a string to look for the value inside the params hash. There's one last thing that you need to know about params, and that is all of the params values are strings. Let me show you why that's important. Let's say that in addition to page, we also wanted to have next page, and we're going to have some Ruby tags here. I'll put a BR after it. So what is next page going to be? Well, it's going to be @page +1, right? Let's save it. Let's come back here and let's just reload this page. I get an error, type error. And the problem is that I tried to add an integer and a string together. This is always going to be a string. If we want to turn it into an integer, then we need to specify 2_i on it. And now it's going to be an integer. And we get the answer we were expecting. So just remember, the values that are inside params are coming from the URL, and Ruby doesn't try to typecast this. It doesn't try to guess that this is an integer. It just always makes them strings. It's up to you to change it into something else if you want it to be a different class.
It's time for a challenge assignment. In this challenge, you're going to use what you've learned about dynamic templates. There are several objectives that I'd like you to try to complete. The first is that in the demo controller, we want to add a couple of new actions, about and contact.
The hash or pound sign that's in front of each of those words is a convention for how we write Ruby method names. So those indicate that this is a Ruby method inside the demo controller class. Of course, once you create these actions, you'll also need a route to route requests to those actions, and we're going to need some templates. But our templates aren't going to be called about and contact. I want you to name them about_us and contact_us. So you'll need to create new files for those and make those work with our controller actions. You'll also want to write some HTML and text for those templates. There's some sample text in the exercise files that you can use, or you can be creative and write your own. You should also add links between those two pages. Use the link to helper for your links. Once you're done, you should be able to fire up a web browser and click back and forth these two new web pages. But we're not done. Once we have the templates, you should try adding dynamic content to them. In Demo Controller Contact, you want to write Ruby code to check for a country parameter. If the country parameter is US or CA, meaning United States or Canada, then we're going to want the template to display one phone number. But if it's UK for United Kingdom, we're going to use a different phone number. And if it's anything else, then it'll be a third phone number. Now, I've given you some examples of what those phone numbers can be, but it can be really anything you want. The whole point is to retrieve a parameter value, to check it against a couple of different choices, and then set a value based on those choices. So the idea is to set the phone number value in the controller and then display it in the view. Let me demonstrate a working version. So in the exercise files, you'll find page_text.html, and it just has a couple of blocks of HTML, some sample text for an about page, and some sample text for a contact page. You can use these if you want, or you can write your own. Once you've got it working, you'll be able to go to demo/about, and you'll be able to see this about page. It has a link to the Contact Us page. Now, when I click this link, you'll notice that it also includes a parameter here, country equals US. That's so that I can see this feature at work. You could set it to be anything you want, but we're setting the parameter in that link, and we're seeing a certain phone number. I can click About Us to go back to that page, and Contact Us will go back again. I want to show you if I change this to instead be UK, you see I get a different phone number. And if I take it away altogether, so there is no parameter, I get a third phone number. I'm dynamically setting the content that's going to appear on this page. Now, in the real world, this might be data that's retrieved from a database, or we might detect the user's location based off of their IP address, or maybe it's a value that's set in the session or a customer preference. The important part is that we're setting a value in the controller and then displaying it in the view. Give it a shot. See if you can apply what we've learned to make a working version. And then in the next movie, I'll walk you through my solution step by step. Hopefully you did well with this challenge assignment. Now I'll show you the solution that I came up with. We know that we want to add two new actions to the demo controller, and we know that actions need to have a route that points to them. So in the route file, I've added two new routes. I've used get and then demo about and demo contact. These are the strings that are going to go in the browser in order to activate these actions. Then in the demo controller, I've added two actions, about and contact. Now, I'm also going to be using two templates for those. At least for the moment, the about page is not going to be dynamic. It's just going to be a static piece of text. But I do need to include render with about_us. That's because I can't rely on the default name of the action to pull up a default template. Instead, I need to specify that it's going to have a different name. Now, I don't need to say what controller it's in. I can still use this same controller as a default. I could also just as easily have said demo/about_us, but that's not necessary. So I've left it off. I've done the same thing in contact. I have render contact us. Now we'll come back to this code here. Let's go look at these templates first. So you can see I have a template here about_us.html.erb. We now know what those line endings mean. ERB means it's going to be processed by ERB, so that any Ruby code that we've put into that template will be processed, and it's going to end up resulting in HTML as the output. Once I have both of those template files created, then I can add content to them. I've used just the sample content that's in the exercise files, but you can feel free to write your own. The important part is that I've got link to here inside ERB tags. So it's going to output the link to tag. Notice the equal sign in front of that. It's important. And the text for the link is going to say contact us. And then the target for the link is going to be action contact. So it'll link to the contact action. And remember, Rails will take that hash and it will go back to our routes to figure out what the actual URL string ought to be. Notice that I've also included another parameter here, the country. Now this isn't explicitly necessary at this point. You could have just as easily left it out for this first part, but I went ahead and put it in there so that it will get appended after the question mark in the URL. So that'll give me that link. Then when I come to the Contact Us page, again, I've got my sample text. I've got a link to that goes back to the About Us page, exactly the same. And notice here, I've got the phone number. I've taken the text from the sample text and I've replaced the static phone number that was there with something dynamic. Notice that I'm using an instance variable. That tells me when I'm looking at this template as a Rails developer that this is probably a value that's being set in the controller. It's being passed off and made available to the template. So this is going to output whatever has been set in the controller. Let's go back to the controller and see what's being set. We know that About Us is sending a country as a parameter. The way we retrieve those values is by using params. And remember, we can use either a symbol or a string here. I'm using a symbol. That's usually what I prefer. It's one character of typing instead of two, so it's slightly faster. Params country, and I'm using Ruby to say, if the country is included in this array of countries, US or Canada, then use this phone number. Set the instance variable equal to that string. But if params country is instead equal to the string UK, then set this phone number. Otherwise, set this phone number. I wanted to give you some examples of some common Ruby expressions so that if you're not familiar with them, you can start to get familiar with them. Notice one thing that trips up beginners is that else if is ELSIF instead of ELSE. It doesn't have the E in there. Once I've got that, I now have the ability to read that params value and to perform some logic on it. I've set a value that's able to show in the template. Everything should be working. So I'll save everything. I'll come over here and let's start up the Rails server and let's try it all out. Once it's listening, I'll go into Firefox. I've already got the page up, but we can try it again now. I'll just hit return. You'll see that it loaded the About page. I'll click Contact Us. Here's the contact page. This goes back to About Us. And when we click on the one to the contact page, we can see that this parameter is being set, country equals US, and we do see the phone number we would expect. Same thing if we change that to be CA, or if we change that to instead be UK, we get a different phone number, or if we change it to be literally anything else, let's make it a JP, and now you see we get this other phone number, this default phone number. So we met all of the objectives of our challenge assignment. There's one last thing that I want to leave you with before we move on. I just want to show you that back in the code, in our template for Contact Us, we have this link for a mail to link. Now this mail to is a normal kind of link, and we certainly could use the link to helper with it. What I want to show you is just that we can actually take that and let's just change it into a Ruby tag. And it's the mail to helper. And if we take the mail to helper and we just simply take the string that we want people to be able to mail to. There we go. I left out a parentheses. There we are. This works as well. So link to has another helper method called mail to that works as a companion. And it works in a similar way to link to. If we save that and we come back here, we reload this page, and you'll see that we get the exact same link. It's going to still mail to press@nowhere.com. So that's just a nice bonus tip.
In this chapter, we're going to be learning to work with databases and migrations. If you think back to the MVC web architecture diagram, we have that triangle between browser, controller, and view. And that's what we focused on in the last chapter. Now we want to move to the right side of that diagram and work on the model and the database. We're going to start with the databases, and then we'll build models that connect to them. In the Getting Starting chapter, we already set up the database that we're going to need for this project. As a refresher, I'll just give you the quick steps that you would need to create them. You can go into MySQL and you can issue commands to create a new database. You can then issue the commands in order to create a new user who has a username and password to log into the database and access data. And then you need to grant privileges for that user to access all the tables on the database that we're interested in. After you've taken those steps inside MySQL, you'll be ready to configure your project to use that database. You can do that in config/database.yml. And a good test to make sure everything's working is to go to the command line and run rails db:/schema:/dump. This command will go to the database and it will output a file that contains the structure of the database. But it proves that your project was able to connect to the database as the user. We don't really care so much about the content of the file that it creates. What we care is that it shows that it's able to successfully connect to the database as that user. So it's able to log in, get information, and dump it to a file. That lets us know that everything is working. So as a reminder, inside the project, inside the config directory, is database.yml, and this is where you need to put your configuration. So you can see that I created a user called Rails user, and my password is just secret password. Hopefully you picked something better than that. And then I've assigned it to have credentials to work on the simple_CMS_development database. That's the Rails convention. I have a development database as well as a test database. And eventually when I make it public, I'll have a production database. You can name them anything you want, but this is the convention. You should already have these databases created. If not, you'll want to go back and review the Getting Started chapter and make sure that you have a database set up and configured before you go on. We've created a database and configured our Rails project to connect to it. Now we need to add tables to the database. There are a few ways that we can manage the database tables. You could be using legacy database tables. That is, you might already have an existing database with data in it, and you're just now trying to build a Rails front end that's going to connect to those tables. That's certainly possible. Or you could manually manage those database tables. You could log into MySQL and issue MySQL commands to create tables, to add columns, to remove columns, and manage it manually from the command line. Or the third option is to use Ruby on Rails migrations. And that's what I want to show you how to do here. A migration is a set of database instructions. And those instructions are written in Ruby, and they migrate the database from one state to another. Essentially, they describe database changes. In our migrations, we can create a table, add a column, change the name of a column, drop a table, and much more. A migration will contain both the instructions for moving to a new state and also instructions for moving back down to the previous state. For example, if a migration has instructions to create a table when moving up, it will also include instructions to allow it to move back down and drop the table. If you move up by adding 3 columns to a table, then you'll have instructions to move back down by removing those same 3 columns. It's handy to be able to migrate in both directions. We can migrate our database to the newest version or migrate back to a previous version. There are many reasons why it's better to use migrations to manage your database changes. Migrations maintain our database schema with our application code. Our application depends on having the database in a particular state. And since they're closely coupled, we want to make sure the description of the database is stored right alongside our application code. Once the instructions are written down, we can execute them anytime and they're repeatable. Let's imagine that I take my project to a new computer and I want to recreate the database there. All I have to do is run my migrations and it'll create a new database in the same state. It also makes it easy to share database changes with other developers. Imagine that I'm collaborating on a project with another developer. If I add a column to one of the tables and I write code that depends on that column, then the other developer is going to need to also add that column to their table in order to use the code that I wrote. If we share the migration file, the other developer can run the migrations and keep their database in sync with mine. Migrations also help with versioning. If you're using a version control system, you can check out a previous version of the code and then migrate your database to put it in the exact state that the code expects. Migrations also allow us to write Ruby code instead of writing SQL. You can still write SQL if you prefer, but Ruby gives us some easy methods that can keep us from having to look up the SQL syntax. And migrations also have access to all of our application code. That's useful if we need migrations that depend on data that's already in our application. Maybe we want to add a new column to the database and then also pre-populate it with data that comes from another table. Migrations definitely make working with databases and Rails a lot easier. Let's see how we can create some. In this movie, we're going to learn how to generate migrations. There are 2 main ways that we can generate migrations. The first is the general all-purpose way. You go to the command line, navigate to the root of your Rails project, and type Rails generate migration, and then the name of the migration. You can see here I've got the migration name in what's called camel case. That is, there's no spaces or underscores. The words are all smashed together with capital letters to indicate where each word starts. This will give me a migration that I can use for any purpose I want. I can put any kind of Ruby code in it, and when I run my migrations, that code will be executed. There's another more special purpose case, which we're also going to use very often, which is to generate models. We know that our database and our models are going to be tied closely together, so you can also use Rails generate model and then the name of the model that you want to create. So if your goal is to create a new model and a corresponding table in the database, you want to use Rails generate model. If you're going to be modifying an existing table or doing other changes, you're going to want the general purpose migration. Migrations are going to be stored in our project inside the DB directory. If I open up now, you see there's nothing in there except this file called seeds.db. We won't worry about that. Let's go to our command line, and from the root of our Rails project, let's try that first command. Rails generate migration, and then let's create our first migration. We're going to call it do nothing yet. When I hit return, it'll take a moment while it goes out, and then it will create this file. You see, it tells you where it's located. Let's go look at that file. You see there's a new directory now in DB called migrate. That's where all my migrations will be stored. And you can see the file it created has a timestamp at the beginning. That shows the time that I created this file, followed by the name that I gave it, this time in lowercase and underscored instead of camel case. Having this timestamp at the beginning is handy because it helps keep our migrations in order, and it also makes each file name unique. And that's useful if we're collaborating with other people. We won't accidentally create two migrations that have the same file name. Let's click on that file and look inside, and I'll just add a couple line returns here to make this easier to read. You see that it is a Ruby class called do nothing yet. It inherits from the active record migration class. That's what allows it to act like a migration and to interact with the database. And you see it pre-populated it with one Ruby method called change. Change is a shorthand for two other methods, up and down. I'm going to write them out instead. Up will describe the changes that we want to make to the current database. Down will describe how to reverse those changes, to undo the code that's in the up method. So if up creates a new table, then we would expect down to drop that table. Change is a shorthand. Rails is smart enough to know the opposite of many of the actions that you put in there. So if you say that you want to create a table, then Rails knows that when you go up, you want to create it, and when you go down, you want to drop it. You only have to define it once, and it can intuit the reverse. But it's good to know how to write both up and down methods in case there are differences. So what do you put inside those up and down methods? You can put absolutely any Ruby code that you want inside of them, and that code will be called when you migrate up or when you migrate down. We'll see how to do the migrations later. For now, just know any Ruby code can go in there, but most often you're going to be using some of the special migration methods. Create table and add column are by far and away the methods you'll use most often. Drop table and remove column are probably the next most common, and renaming tables and columns happens sometimes as well. There are others as well. You can change the configuration options on tables, add indexes and foreign keys, and all sorts of others. But by far and away, these are the methods you're going to use the most often. Now we're not going to put any of those in here. We're going to leave this migration as blank. Let's go back to our command line and let's try that second one. Let's do Rails generate. This time we're going to generate a model, and we're going to create the user model. Now I could just hit return here and it would create the model and migration that I need, but I'm going to do one extra thing, which is that I have the ability to do a shorthand here that'll save me some work later on. I can tell it what columns I want and what types of columns the database table should have. So I'm going to have a first name column. So I'll type first underscore name, and it's going to be a string column. Then I'll put a space, and I'm also going to have a last name, which is also a string, and then a space, and I'll have email, which is also a string. Now that last part is not necessary, but you'll see what happens when I hit return. It'll generate this model file for us. You can see the migration it created. It also created a placeholder in the models directory for our model and created some tests so that we could test our model later on if we wanted to write tests for our code. We'll look at models in the next chapter. For now, let's look at this migration file it created. Let's go back to our text editor, and you can see it created a new file in Migrate, also has a timestamp. It named it create_users. That's the name it automatically gives when we're creating a model. And you can see it also populated it with this change method, but it added a bit more inside there this time. This time we have the create table method being called. It went ahead and added that for us. The name of that table is going to be the users table. The default in Rails is lowercase and plural for table names. After that, you can see that it has a code block that's everything from do to end, and t is a variable that's available inside that code block that refers to the table. So on that table, it's going to add a string column called first name. And on that table, it'll add another string column for last name and another one for email. If I had left those lines out here, if I had not added this when I was generating my model, it would have created exactly the same thing, except these 3 lines would have been blank. Timestamps, it adds automatically as a default. And that adds timestamps to every model for created at and updated at. And those 2 fields are a little bit magic because Rails will automatically keep track of when any record was created and when it was last updated. So it's nice to leave on there. Now, those of you who have some database experience may be wondering, well, what about the ID column? Usually most database tables have a primary key called ID. Well, we could add something like t.integer ID, but we don't have to because Rails does that for us by default. It knows that anytime we have a record that corresponds to a model, it's going to need an ID to go with it. So it's built in and there's no need to specify. You can add options here after users if for some reason you don't want it to create the ID, but otherwise you don't even need to think about it. Okay, now that we have a couple of migrations, in the next movie, let's learn how to run them. Now that we've created migrations, we're going to learn how to run them. The way that we run migrations is by going to the command line to the root of our Rails project and typing Rails space db:/migrate. Rails will then run any migrations that have not been run before. In the last movie, we created 2 migrations, do nothing yet, and create users, but we haven't run those migrations. We have not put the database in this state. Right now, this exists only as code. What we want to do is tell the migrations that they should run this code, thereby creating this users table on the database. So make sure that you've saved both of those files. Let's go to the root of our Rails application. We'll type Rails db:/migrate. You'll hit return. It'll take a moment while it goes and grabs that code. It'll then execute it and update the database. You can see that it tells you what it did. It gives you the timestamp for each of the migrations, and then any feedback that is necessary can be output here. You can use Ruby puts commands in the migration file if you want it to output something special here. You can see that create table has output telling us that it created its table users and how fast it was created. Now our migrations have been run. If we want to see that, we need to log into MySQL. So let's log in MySQL-u Rails_user-p so I can enter a password and then the database name simplecms_development. Once I enter my password, now I'm inside MySQL and I can say show tables because I'm already on the database I want. You can see here's the users table. And then if I type show fields from users, it'll come up and tell me the different columns that it created. You can see that it created the ID column for me automatically. It went ahead and made that the primary key and set auto increment on it. And then the ones that I defined, the custom columns, first name, last name, and email, and then timestamps were created automatically. And then that line that created the timestamps added created at and updated at as date time fields. Notice also that even though I defined the first name column as being a string column, it converted that to the MySQL type, which is varchar, a variable character length field. Now that's because the migrations try to be database agnostic. They don't try to be too closely married to the MySQL way of doing things so that your migrations could use a different database adapter to talk to a different database. Let's say Oracle, for example. The Rails code wouldn't have to change and the adapter would be the thing that would translate string into whatever the appropriate column type was. There are a couple of other tables already on our Simple CMS development. AR internal metadata is something that's used by Rails, and we don't need to worry about it. You're never going to use it. Schema migrations, though, is interesting because it has to do with our migrations. Let's take a look at what's in there. Select all from schema underscore migrations. So now we're looking at the records that are stored in that table. And you can see it has one column called version, and in there it stores those timestamps. Do you recognize those? Those are the timestamps for our migrations. Let's come back here and open up the text editor, and you can see that those match right here. So that's how Rails keeps track of which migrations have been run and which ones have not been run. So if we add a new migration now, Rails won't execute this code a second time. It will look in here, it'll see that 2 migrations have been run, it'll skip those 2 and only run the new migrations next time. There are also a couple of other handy commands to know about migrations. One is railsdb:/migrate:status will show you the status of the migration so you can see what's up and what's down. You can use railsdb migrate followed by version in all capital letters equals 0. That will undo all migrations. That'll go back to the beginning. So it'll take every migration that's been run and call its down method so that eventually we have presumably a database with no tables in it. And then railsdb:/migrate version followed by one of those timestamps, and that will migrate up to that specific version and then stop. If you don't provide the version, then it goes all the way to the latest version. If you provide the version, then it'll stop at that particular version. We can see these in action if we exit out of MySQL. Let me just clear the screen. Let's try railsdb:/migrate:status. It'll give us a list of the migrations. You can see that it tells us our database, it tells us the migration ID and its name, and it says that it's currently up. Now let's try the railsdb migrate space, all capital version equals 0. And now all our migrations will run down. So it says reverting, right? It's reverting each one of those. Now, if we hit the up arrow twice, railsdb migrate status will run again. It'll tell us that they're both down. It has removed that table. So now the users table is no longer in the database. If we want to go up to a specific migration, we can. I'm just going to copy this value and let's hit the up arrow. And instead of version 0, I'll paste in that ID number. And now it'll migrate just do nothing yet and then stop. So it did whatever code was in there, but it did not create the users table yet. If I either add the latest version or if I completely remove it, then you'll see that it will just migrate that second one. It knows the first one has been run because it stored this ID value in its schema migrations table. It knew that there was only one that hadn't been run, and now they're both in the up state. You can play around with running these migration versions on your own. When you're done experimenting, make sure that you fully migrate so that all the migrations have been run before you continue with the tutorial. It's time for a challenge assignment. And this time, your challenge is going to be to create the migrations we'll need for the content management system. First, let's get an overview of what the CMS is going to look like. The idea is that there'll be a navigation that shows us a number of subjects, and below each one of those subjects is going to be a set of pages. So for example, there might be a subject that's about the products, and below it would be a page for each product. And then on the right side, we would have an area that would display the actual content from the page itself. So the left side is a navigation, the right side shows us the content that we want to look at. Now, in order to make this work, we have to have a relationship between those subjects and the pages so that pages know what subject they belong to. This is a common feature of relational databases. And the way that we do it, the way that we have one subject that has many pages, is we use something called a foreign key. Subject has an ID. So every record that's a subject has an ID stored in the database. So maybe we have subject ID 17. Then we have a series of pages. They have an ID as well, but they also have another column called subject underscore ID. It can be named something else, but that's the Rails convention. Subject underscore ID is a foreign key to the subjects table, and it stores the ID of the subject table so that a page can look to that value and know which subject it belongs to. Your challenge assignment is to generate models for the subject and the page. The subjects table will of course have its standard ID column, but it's also going to have a name, a position, and visible. Name is going to be a string column, position will be an integer column, and visible will be a Boolean. true or false. That'll determine whether a subject is visible in the navigation or if it should be hidden. The pages table will of course have its standard ID column, but it will also need that foreign key in subject ID. We'll talk a bit more about that in just a moment. And then we're going to have its name, its permalink. That's going to be the part of the URL that we'll use to identify a page so that we can pull up a page based on its permalink. Then there will be the position so that our pages can be put in different order, visible to determine whether a page is visible or not, and then the content of the page. That's going to be a text field. The difference between a text column and a string column in databases is just a matter of size. String columns are typically very short, whereas a text column can contain lots and lots of information. So the foreign key can be set a couple of different ways. You can just simply specify an integer column on the table that is subject ID, but we also want to include index true on there. It's a best practice to include indexes on your foreign keys. If you think about the index that's at the back of the book, it allows you to find things in the book quickly. It's like a reference table for finding things quickly. That's what happens here. We're essentially telling the database, you know what? We're going to be using this relationship between the page and its subject very frequently, so keep good track of it so we can use it very efficiently. Now, we could write it out that way, or Rails gives us a couple of shortcuts. You can use t.references and then just subject. You don't need to put _ID after it. We're just saying the page references the subject, or even better, you can use t.belongs to subject. In this case, the page belongs to the subject, so it knows that it needs to create a foreign key and put an index on it. Once you've created those two migrations, then run them. Run them all the way up, run them all the way down, try running them to different versions. In the next movie, I'll show you the solution that I came up with. In this movie, I'll show you the solution that I came up with to the migration challenge. The first thing I did was I came to the command line and I made sure I was inside the root of my Rails project. Then I ran Rails generate, and I had to choose, do I want to generate a migration or a model? Since I'm creating a new model, a brand new table with a model attached to it, I wanted to choose model. And that model is going to be the subject model. And I went ahead and provided the names of the columns and the types of columns here as a list. Again, this is an optional step. You don't have to do it, but it's a nice shorthand. So I'm going to create a name column, position, and visible. If we jump over to the code, you can see that it created that file, create subjects, and it has create table, subjects, lowercase and plural. And you can see that it has name, position, and visible as a string, integer, and Boolean column. And then timestamps is there by default to keep track of when each record was created and last updated. Then I came over and did the same thing for page. So Rails generate model page, and then I put in that long list of columns. There's a name column, permalink, position, visible, and content. I did not include anything for subject ID. I did that by hand. You can see it has create pages, create table pages, and then I added belongs to subject. So that's going to add that foreign key. I like to put that right at the top of my tables so that it's right there at the very beginning. And it's going to automatically add that index to it because we used belongs to. So we don't need to add it. Once we've saved both those files, then we're ready to run it. I haven't done that yet. So let's come back over here and run Rails DB migrate. Rails runs just my two new migrations. It knew that the other two had already been run, and it had no problem at all. It created both of those tables. If we want to migrate back down, we can go all the way back down with version equals 0, and it will undo all 4 of my migrations. You can see it undid create pages, create subjects, create users, and do nothing yet. And I'm just going to hit the up arrow to migrate back up, and it will run all 4 of those again. It will reissue those MySQL commands so that it created the users table, created the subject table, and created the pages table. If I made a mistake in one of these, then I could just migrate it back down, come over and make some edits to the definition that I've put in the migration, and then migrate back up again. And what's great about this migration is if I'm working with other people, I can now commit it to the version control system, push it up to a remote repository. They can pull it down into their projects, and then they can run the migrations and create the exact same database tables that I've got.
In this chapter, we're going to be talking about models and active record. And we'll start by learning about active record and active relation. If you think back to that MVC web architecture diagram,
We've now looked at all of the parts that are there except for the model. In the last chapter, we generated a model, which generated a corresponding database table at the same time, but we haven't actually talked about how the models work. So that's what we're going to do in this chapter. And to do that, we need to first understand active record. When you see active record as 2 words and all lowercase, it's a design pattern for relational databases, and it's not unique to Ruby on Rails. Other programming languages use the active record design pattern as well. When Ruby on Rails implements that design pattern, we call it active record, all run together with a capital A and R. Active record allows us to retrieve and manipulate data from the database as objects, not as static rows. And it's very powerful, especially when paired with the object-oriented programming of Ruby. Active record makes our objects intelligent. Our objects understand the structure of the database tables, and they know how to interact with them. They contain not only data, but they also contain code for creating, reading, updating, and deleting rows in the database tables. Therefore, these objects can be manipulated and saved back to the database with just a few simple commands. Let me show you an example so you can get a feel for it. Here's some Ruby code where I'm interacting with a user object. I start out by setting the variable user equal to a new instance of the user class. The user class is going to be an active record class, and it's going to have a database table called users behind it that it can interact with. Next, I'm going to set the attribute for first name equal to Kevin, and then I can call user.save. With that one simple command, active record will write an SQL insert statement and insert a row into the database table. This is much easier than writing raw SQL, especially once our database objects become more complex. Next, I can set the attribute last name equal to Skoglund. Then I can call user.save again. This time, instead of doing an insert statement, active record knows to do an SQL update statement, because active record keeps track of the fact that this object has already been stored in the database. So it not only constructs the SQL, it makes smart choices about the kind of SQL that it should write. And last, I call user.destroy, which writes an SQL delete statement that'll delete a row from the database. With just these few simple commands, I can work with my database data in an object-oriented way. It's easy to use and easy to understand, and I can let my objects handle writing all of the SQL that's needed to get the job done. That's what I mean by intelligent objects. So if that's active record, what is active relation? Active relation, also sometimes called ARRL for short, is an object-oriented interpretation of relational algebra. Now, you do not need to understand relational algebra or even know what it is. The whole point is that Ruby on Rails handles it for you. Active relation is going to simplify the generation of complex database queries. What that means in practice is that we can chain small queries together, like you can for most Ruby objects, and then it will handle combining those together into creating complex joins and aggregations that use efficient SQL. And in addition, the queries that we create are not going to execute until they're needed. Here I have users as a variable that I'm setting equal to the user class, and I'm calling the where method on it. That's going to perform a find on the table. So it'll go out to the database table and it'll find all of the records in the users table where the first name column has a value equal to Kevin. Now this is an example of an active relation query, and you may be surprised to realize that it doesn't actually go to the database right away and try and find those records. Instead, we have the ability to chain more queries on top of it. So here you can see I'm setting users equal to whatever users was set to, but also chaining on a order method and a limit method that'll control the sort order and how many records get returned. Still, active relation will not go to the database and actually execute the query. But as soon as we call something that needs those records, such as users.each, well, then it says, all right, I need those records now. It goes out to the database and it retrieves them. And when it does that, it'll take whatever we've given it as all of those smaller queries and put them all together into sensible SQL. Together, you're going to find that active record and active relation are very powerful tools for allowing you to work with your databases inside your Ruby code. The Rails console is a useful tool. It's especially helpful because it allows us to experiment with the project's models in isolation. We're going to use it to explore the models without having to worry about the controllers or views. The way that you launch the Rails console is you go to the command line and navigate to the root of your Rails project, and then enter the command Rails space console. And then if you want to specify the environment, you would use -E and the environment. So for example, -E development, -E production, or -E test. Most of the time, we're going to be using it in development. So we can just leave the -E option off and development will be chosen by default. If we're on production though, you will need to specify it. You can also shorten it to just Rails space C. In the same way that we do Rails space S to launch the server, Rails space C will launch the console. So from the command line in the root of my Rails application, let's start out not by launching the Rails console, but launching IRB. That's the interactive Ruby console that comes with Ruby. If you've never used this before, it's a lot like a calculator. So I can execute Ruby commands in here from the command line. For example, 1 + 1 comes back and tells me the result is 2. Or I can do hello.upcase.reverse, and it will return the result back. Now this is not Rails, this is just simple Ruby. Let's exit out of there, and now let's try the Rails console. Rails console, and it'll launch, and it tells me that it's loading the development environment, and it tells me what version of Rails I'm using. It gives me a command line, and notice it still says IRB here, because the Rails console is essentially just IRB, but with our Rails project loaded in, so that we have all of the models and the code and database access that's in our Rails project that we can still access from the command line. So we can still do 1 + 1 or hello.upcase.reverse, but we can also now access our models. So for example, we can do subject equals subject.new. And because I have that model for subject that was created in the last chapter, now I have a subject object, and it has attributes on it: ID, name, position, visible, created at, and updated at. These correspond to the columns in the database table. Let's do subject.name equals test. It set the value of subject named test. If I do subject.name, it returns that value. Now this is not saved to the database. This is the object that is in memory. I would need to type subject.save in order to save it to the database. I'm not going to do that right now, but I do want to make an important point that we are interacting with the same development database that we would see from a web browser. They're one and the same. So if we make a change here, that change is going to affect what we see in a browser. That's especially important to remember once you deploy your project to a production server. So it's out there in the world for public to see. The public is seeing your website and all of your production data. If you log into the Rails console, you will be interacting with the same data that the public sees. You don't want to suddenly delete all the data, or it'll be deleted for the public as well. So just be mindful of that. When we're done with the console, we can type exit to get back to the regular command line. We're going to be using the console throughout the remainder of this chapter so that we can focus exclusively on how our project models behave. In this movie, we'll use the Rails console to access our models and to create new records in the database table. I'm going to show you two different techniques to accomplish this. The first I refer to as new plus save. It's a 3-step process. First, we instantiate an object. Instantiate means to create a new object of the class. This object is also called an instance of the class. And then we can set values on that instance. Once we have all the values set, we can save the object to the database. That's the 3-step process. Instantiate, set the values, and save it. The second technique is to do it all in one step using create. It has the same effect as new and save, it's just one single command. Create will instantiate the object, set the values, and save it. Before we go to the command line and try this out, let's just go into our app and let's see the models that we've already created. We have models for subject, page, and user. Let's click on subject.rb. You'll see that it's just a very simple Ruby class that inherits from application record. Now, application record is also a model here, but it's a model without a database table. And what it does is it inherits from active record base. You're really not going to put much in application record. It's really only here in case you need to be able to put code that applies to all of your models, because all your models inherit from application record. It's rare that you need that. Instead, what's really happening is that active record base, all of its behaviors, all of its attributes are all being passed along to each one of your models so that they have all that behavior, even though they don't have any additional code of their own yet. Let's see some of the behaviors it has. Let's go over to the command line, and from the root of my Rails project, I'll type Rails console to enter the Rails console. Once we're there, let's create a new subject. Subject equals capital subject, and then .new. That's going to call the new method on subject, and I could just hit return and create a new instance, but I'm going to put parentheses and then provide a hash of values. name equals first subject, and visible is true. I'll hit return, and you'll see that it created a new instance of the class. That's step one. Here's my instance. You can see that it went ahead and took those values that provided and set some of the attributes. Now it didn't set all of the attributes. We can also set subject.position equals 1, and we can get back these values as well. Name, subject.position. And you can see that those are all set. We can work with these in an object-oriented way. Now let's try subject.new_record ? This is another one of those built-in behaviors in Active Record, and it will tell us whether or not this is a record that has been saved to the database or not. So it has not. It's a new record, not yet saved to the database. We can also type subject.id and see that it hasn't been given an ID yet, which is what we would expect if it was saved to the database. So now we've done steps 1 and 2. We instantiated an object, we set its values. Now let's do step 3, subject.save. And there it is. It saved it to the database. And we know that because it gave us output of the SQL statement that it created. Notice that it also returns true or false. This is very useful if we want to have a conditional that'll perform one action if the save succeeds or another action if the save fails. Now, if we hit the up arrow and try subject.newRecord again, it comes back and says false. It's not a new record. It has been saved to the database. If we hit the up arrow to get subject.id, you can see that now its ID is 1. We can also do subject.created_at and subject.updated@. Those are magic columns that Rails automatically populates for us when it saves a record to the database. So if we have those columns, Active Record will automatically tell us when any record was created and updated. Now let's look at the second technique using create. Let's do subject again. I'll do subject to this time so we won't be confusing. Subject equals capital subject again for my class. I'm going to create, and let's also provide some attributes to create. So we'll have name, and this will be second subject, and we'll give it visible equals false. Now this time it was a one-step process. As soon as I hit return, this create method that is inherited from Active Record went ahead and created the record in the database, or at least it tried to. It didn't return true or false to us this time. Instead, it returned the object that it created. And that's useful. We want it to return the object because I'm assigning that to a variable. And then I can ask that variable, which contains the instance, are you a new record? And it'll come back and say, no, I'm not a new record. I have been saved to the database. Subject to.id, and you can see that it has an ID of 2. Now you know 2 ways to create new records in the database. We did it from the console, but you could use these same techniques inside your controllers. In the last movie, we used our models to create records in the database. In this movie, we will learn to update those records. Like creating records, there are 2 techniques we can use for updating. The first I call the find and save technique. First, you find a record, then you set its values, and then you save it. It's very similar to what we were doing when we were working with new before. We're finding the record so that we have an instance to work with, we set the values, and then we save it. The second technique is what we would call find and update. We still have to find the record, but then we set the values and save all in one step. So it's a 2-step process. Let's try them both. If you're still in the console after the last movie, that's fine. There's no need to exit and go back in, but I will launch my Rails console again. The first step is to find the record that we want. So we'll have subject equals capital subject for the class name, and then we're going to use the find method, and I'll put a 1 in parentheses. The simplest way to find a record is to find it by its ID or its primary key, like this. When I hit return, you can see that it issues an SQL command. It goes to the database returns a row of data, it takes that data and it populates the attributes of an object for us and gives us that object back to work with. I've set that to the variable subject, so I can type subject.name. You can see the name of the subject. Let's change that to something else. Subject.name equals initial subject. I'll hit return. Now the value has been changed with the object that I'm working with in memory. If I type subject name again, you can see that's the value I'll get back. But if I were to go back to the database and ask for a fresh copy of the data, it would be the saved version, which is first subject. It would not be my modified version. I have not saved this change yet. This change only exists to the object in memory that I'm working with. When I type subject.save, it does the third step, which is that it saves it to the database. Notice that it knew to write an SQL update statement. It knew this was not a new record, that it already existed. So instead of writing an insert statement like it did in the last movie, it knew to write an update statement. Also notice that it was smart enough not to update every single one of the attributes. We might have hundreds of these inside an object. Instead, it only updated the ones that had changed. It knew that name had changed and needed to be set to initial subject, and also knew that the value of updated at needed setting. Nothing else needed to be sent to the database. Now let's try the second technique. I'm just going to clear my screen. Now let's type subject2 equals capital subject. Again, we'll use find. This time I'm going to find record number 2. So that's going to be an ID of 2. It goes and finds that record, gives me back an instance. Now I can ask that instance to update using some values, name, and I'm going to change this to next subject. And let's also set the position to be 2. Now, before I hit return, I just want to make one note for you, which is that this method is called update, but for many years in Ruby on Rails, it was called update_attributes. So if you see anything referring to it as update attributes, they are synonymous, but a transition is being made right now to go with update all the time. And in 6.1, you probably will have to use update all the time, so you should get used to it now. Okay, so let's hit return, and you can see that it issued an update statement all in one step. I didn't have to set the values and then save them. Instead, update let me just put those in all at once, similar to what we did with create. We've seen the two main ways that you update records. We use these in the console, but you could update records from a controller action in the same way. We've seen how to create and update records. Now let's learn how to delete them. Deleting records is a two-step process: find and destroy. First, you find the record in the database table. Rails uses the data that it gets back to populate and return an instance of the class, and then you tell that object that it should destroy itself. There's only one pitfall that you need to be careful of. We're talking about deleting records, but the method we're going to be using is called destroy. Destroy will create an SQL delete statement. There's also another method in Rails called delete. It also sends an SQL delete statement. These two methods may seem to work the same way, but delete bypasses some Rails features and might give you unexpected behavior. Most of the time, the best method to use is destroy. If you're still in the Rails console from the last movie, that's fine. There's no need to exit, but I'm going to start fresh. Rails console. First, let's do some setup. I'm going to create a new variable called bad and create a new subject in the database that I can then destroy while leaving my other ones in place. So we'll call this bad subject. And it created a new subject. Notice here its ID is 3. That's important. So now we're ready to start the delete process. We're going to delete that record we just created. And the first step is to find the record. So let's do that. We're going to assign it to subject. Subject is equal to subject.find. And I'm going to put parentheses 3, so it finds it by its ID, which is 3. So now my subject variable contains an instance of this object. The way that it created that instance was that Rails went out to the database, retrieved data, and populated the values. So now I have an object, and that object is smart. It's smart enough to know how to destroy itself. So we just say subject.destroy. Again, it's destroy and not delete. I'll hit return, and you'll see that it creates a delete statement in SQL. Now, the record is no longer in the database table, but I do still have the object available for my inspection. For example, subject.name. I still am able to see this object in Ruby and get its values, even though there is no underlying database record. But I can't change any values. Subject.name equals test. You'll see I get back an error. Can't modify frozen hash. When a row is deleted from the database table, the object in Ruby is frozen, so it can no longer be modified, but we still have it available for inspection. And that's handy because we can refer to it in our application. For example, we might have a controller action that deletes a customer record in the database. We might then, after deletion, want to display a message back to the user that says the customer named John Doe was destroyed successfully. To do that, we need to have that name available, but it's not in the database. In fact, if we do, let's do missing equals subject.find3, you'll see that this time it can't find it. It's not there. Could not find subject with ID equals 3. If you just remember to use destroy instead of delete, it'll be easy to delete records either from the console or in your controller code. In any Rails application, you will query for existing records far more often than you will create, update, or delete them. Active Record and Active Relation offer many tools to make finding the right records easier. Let's begin with the simplest method, the primary key finder. This is the type of find that we've been using. You start with the class name, in this case subject, and then you call the find method on it. And the argument to find is going to be the primary key. Most often that's going to be the ID. So we're asking Rails to go to the subjects table and find a record whose ID is 2. The result will either be an object if it finds the record, or it will raise an error if the record does not exist. You would use the primary key finder when it would be surprising if the object wasn't in the database. For example, if you do a database query and retrieve a list of all customers, then when you use one of those IDs to examine more details on a particular customer, it'd be reasonable to expect that customer to still exist in the database. Another option is to use conditions to narrow down search results. For that, we use the where method. This is asking for all subjects where visible is equal to true. I'm providing a hash as the argument to where, and Rails takes that and converts it into SQL. I've only got one key value pair, but you could have many, and Rails would join them together as AND clauses. So for example, you could have subject where visible is equal to true and position is equal to 3. A hash is not the only thing you can send to a where clause. You can also provide an SQL fragment as a string. Here, I'm asking it to find the subject where visible is equal to 1 and the position is less than 10. Notice that less than sign. Inequality operators like less than and greater than are one of the most common reasons that you'll use an SQL fragment. One word of warning though about SQL fragments. You don't want to drop dynamic data into them. We call that interpolation. You don't want to interpolate a string inside the string that you're sending. The reason why is that if the string contains malicious data, it can create an SQL injection. That's one of the most common web application vulnerabilities, and it can compromise your entire database. Instead, if you need to drop in dynamic data, you want to pass in an array, and the first value in the array should be a format string. And that format string can contain one or more question marks as placeholders for data. And then the other elements in the array can be the data that you want dropped into each of those places. The SQL that it generates will be exactly the same. The difference is that Ruby on Rails will sanitize the data so that it can be dropped into the string safely. Each of the conditions we just looked at will return an array of values. If you want to return just a single value, then you can use .first to extract the first object from the array. So it'll either return an object if there is something, or if the array was empty, it'll return nil. You can also combine your conditions with order, limit, and offset. Order is used to determine the sort order of the records. Limit allows us to limit the number of results that are returned. That gets used most often if we want to display a page of results. Let's say we want to have a page that displays only the first 20 subjects. Well, then we would use limit 20. We would click next page to see the next set of results. That would also be limited by 20, but we wouldn't want the same records returned, so we would use offset to tell it how many records to skip. So it would skip over records before returning a limited result. And you can daisy chain all of these together. For example, I can have a subject where visible is equal to true, sorted by the position, and limit it to only the first 5 records. Let's try these in the console. I'm in the root of my project. I'll launch the Rails console. And let's start by just doing subject.find, and let's do 2. So that's going to return the record whose ID is 2. Notice that it just returned an object to me. That's what an object looks like in this console notation. It's a representation of the object. Now let's try another version. Let's do subject.where, and let's do visible is true. Now it returned an array to me. See, there's an object that's inside the array, but see those square brackets? It's an array of results. Even though there was only one object in the array, it didn't return the object, it returned an array. If we want to get the object itself, then we have to put .first after it. Now it returned just the object. It retrieved the array and then pulled the object out of it. Notice that it also called limit 1 here when it did that, so that it limited the results to 1. That's a little different though than if we do limit 1, because when we call limit 1 this way, it returns an array that is limited to 1. It limits it to only being one item in the array, but it doesn't pull the object out of the array like the other one does. You can try some other examples. Let me clear the screen. Let's do subject where visible is true. And let's also add on to that position is between 1 and 3. I'm using a range there. So now it's returning all records that have visible and our position is 1 to 3. I could also do everything where position is an array of 1, 2, or 3, pass in an array. Or we can also make this two different where statements. Here's the first one. Let's do where, and it will join them together. Notice that the SQL is the same. Now you may also notice that it puts this limit here. That's actually just the default for the console, so that we don't end up showing a ton of objects while we're in the Rails console. It limits the results that it shows us on the screen to just 11. If we were actually capturing these values and using them for something else, it wouldn't be similarly limited. It's just a quirk of the display. And finally, let's do something that looks kind of like a real world example. Let's imagine that we're in a controller and we want to set an instance variable for subjects that we're going to use on a page. So we're going to iterate through the subjects and display them all, let's say. So we would do subject.where, all of them are visible. And let's sort them by their position. I can use a symbol instead of a string if I want to take the default of being ascending. And then let's limit it to 20 results. Again, you're seeing a limit of 11 there. That's just a quirk of the display. The actual limit being set is 20. By using a combination of these find methods, you can zero in on exactly the results that you're looking for. We've been working with a single model and its database table. Rails also makes it easy to work with the associations between tables. There are three types of database associations: one-to-one, one-to-many, and many-to-many. And by far and away, the one you'll use the most often is one-to-many. So that's what we're going to be looking at here. A one-to-many relationship is used when an object has many other objects which belong to it exclusively. To get an idea of a one-to-many association, imagine a teacher. I've named the teacher Martha Cook, and Martha Cook is teaching several courses exclusively. She has an algebra course, a geometry course, a physics course, and a programming course. You can say that the teacher has many courses, or you could say that each course belongs to a teacher. There's a relationship between them, and we keep track of this relationship by using a foreign key that's on the courses table. That means that there's a column in the courses table that contains IDs of the teacher that each course belongs to. So if we went to the record for algebra, its foreign key column would have an ID that is Martha Cook's ID. It allows us to know that algebra belongs to Martha Cook and that Martha Cook has many courses, including algebra. In order to create associations, you first have to create that relationship in the database and make sure that you have the foreign key in place. But that's not enough. In Rails, you also need to tell Rails about the relationship in the models. And you have to do that on both sides so that both of the related models have code that tells them that they're related to each other. When you define the relationship in the models, Rails adds a lot of behaviors into them, and you can use those new behaviors to work with the relationship. So in our simple CMS project, we've already created the underlying database tables and we put that foreign key in place. Now we just need to define the model relationships, and that's easily done by just adding 2 lines to each one of the classes. In the subject class, you add a line that says has_many, and then :pages. That's pluralized because it has many pages. It makes sense it would be plural. And then in the page class, you add belongs_to, and then a symbol for subject, singular, because a page belongs to a single subject. That's it. Once you've defined those relationships, Rails loads in a lot of behaviors that make it easy to work with them. For example, you can call subject.pages to get a list of all of the pages that belong to a subject. Or you can use the append operator to add a new page onto that list of pages. You can use delete to delete a page from the set. You can call pages.empty to find out if it's an empty set, or pages.size to find out how many are in there. These are just a few of the many behaviors that get added automatically. Let's try it out. Let's go into our subject class and let's add has_many: pages. I'll just add some line returns there. Save the file. Let's go over to page and let's add belongs to and then subject singular. Let's save that file. Once we have both of those relationships in place, Now the behaviors are available to us. Let's go to our Rails console and we can try them out. So let's start by finding a subject. We'll use subject.find1 to find it by its primary key. Now we can try subject.pages and we'll get back a list of the pages that belong to the subject. You can see the SQL that it's creating, and you can see that foreign key is right here. It's finding pages where the subject ID is 1. There are no pages currently listed. We also could call subject.pages.empty to ask it, is it empty? And it comes back and says true, it is empty. There's nothing in there. So let's add something. I'm going to clear my screen. Let's create a new page. We don't have any pages yet in our database. This one will be called first page, and we'll make it visible, true. I just called new, so I've now got an instance of the object. Let's add page.position equal to 1, and page.content we will set to this is the first page. And then let's set page.subject equal to the subject that we found. So there it is. It added the subject to it. Now we still haven't saved this object. If we type page, you'll see it still has ID nil. So let's save it now, page.save. It added it to the database. So now we have a record in the database that has subject ID set. So now if we ask for subject.pages, you'll see that we get back a page. Here's that page that now belongs to the subject. It returns an array of the pages of which there's 1. And if we type subject.pages size, it comes back and tells us how many there are. There's just 1. Let's try creating a second page. Second equals page.new. Let's give this one a name of second page and make it visible true. I won't worry about the other ones. Go ahead and give it a position. Position 2. Okay, so this doesn't have a subject ID yet. Let's just try saving it without that, right? There should be nothing to prevent us from saving it, but I want to show you that there actually is. Second save comes back and says false. It did not save it. And the reason why is because this is not optional. We can specify it. There is an option that'll let you say that it belongs to the subject and it's optional, but in this case, it's not optional. So we can't save it, but we can either add a subject the same way we did earlier up above, where we set page.subject equal to subject and then save it. Or let's use that append method, subject.pages, and let's append onto the subject's pages this new page, which is called second. When I make that append, it goes ahead and does the insert into the database for us, right? Because it needs to save it so that subject ID is there. If it's going to add it to the subject's pages, the only way subject can find it is if that ID exists in the database. So it does the insert for us. Now, if I say subject.pages count, comes back and says that there are 2. Count is a synonym for size. And there's a lot more that you can do with these relationships. For example, I can ask the subject for the pages which are visible. And it will return only the visible pages. I've put a query onto the relationship. So there's a lot more that you can do with this, but this is enough to get you started using one-to-many associations. In this chapter, we're going to introduce some concepts that underpin the way most modern web applications are built. And we'll start by talking about CRUD. What is CRUD? CRUD is an acronym that stands for create, read, update, and delete. These are the 4 major operations that we perform on a set of data in the database. We create new records in the database, we read records back out of the database, we can update the data in those records, or we can delete them. CRUD is a term that we can use to refer to all that stuff that we normally do to a database. And our web application is probably going to do the same stuff. It's going to be creating, reading, updating, and deleting records in the database. Many of us have built websites with disorganized web pages full of spaghetti code. CRUD helps us to think about our code in a more organized and structured form. And using it as a standard pays big benefits as your code grows and becomes more complex. In a web application, each of the elements of CRUD typically has 2 actions that go along with it. So for create, we have new and create. New would display a form for a new record. The user would enter information into the form and then submit the form to the create action. The create action would try to add it to the database. If there's a problem, it would likely redisplay the form so that the user could fix those problems and try and submit it again. So they work as a pair, a form and an action that processes the form. Update and delete work the same way. Edit and update, delete and destroy. The delete action that displays a form is not strictly necessary, and it's the one that's most often left out. But you could display a form that says, hey, it looks like you're about to delete this record. Are you sure you want to proceed? And if you chose to submit it, then destroy would be the action that actually does the destruction. Read works a little differently than the others because there's not a form. It has two actions. One is index, which is something that displays a list of the records that are in the database, and then show, which allows you to zoom in on a detailed view of a single record. Notice in the far right column, there are examples of URLs that we can use for these. Each one of them starts with the name of the object or the database table that we want to be working with. In this case, it's subjects. And you can see that following subjects is the name of the action. It's very organized. For some of those actions, there's an ID that's needed so that we can identify which record we're talking about, and then for other ones, it's left off. In the case of index, you can add index after it, but most often it's just omitted because web servers usually assume, if you haven't given it something else, that index is what you're looking for by default. Using this kind of structure has become a best practice, and Rails embraces it, and you should too. Using this structure most often means that you're going to have separate controllers for each one of the tables that are in your database. So for example, you would have a subjects controller or a pages controller. So often it's one controller per model, and you're going to use plural names for the controller, whereas the models are singular names because they define the behaviors of a single row. Here we're going to use plurals. And if we use CRUD, we're going to end up with clear, well-structured URLs like subject/new, pages/new, subject/edit, pages/edit. It makes it very clear what is the object that we're working with and what is the action that we're performing on it. You can think of that as being a resource-oriented approach. The resource is the object, and we're performing actions on that resource. Let's try creating controllers for these. If we go into the app, inside our controllers, you see we just have our demo controller right now. Let's go to the command line, and you should remember how to generate a new controller. We did that before. And we'll Rails generate controller, and then subjects plural. And then after it, I'm going to add a list of the actions that I want it to create. I'm not going to put in all of those actions that we just saw, only the ones that have a template associated with them, because this is going to create both the action in the controller as well as a template. So if it's one that has a template like index, show, new, edit, and I'm also going to add delete. Delete is optional, it's sort of a special case, but I'm going to go ahead and put it in there. So this will generate that controller, and then I can hit the up arrow and use the cursor to go back, and I'll change subjects into pages and create one for pages as well. Now we'll come back over here. We'll take a look in our controllers directory. You can see we have subjects controller, and it has those actions. If we look in the views, and we'll see that it created views for each of these as well. Now let's also add the actions that don't have templates to go with them. We have index and show. New will show a form, which will then submit to create. And edit will show a form that will then submit to update. And let me just get the spacing right here. And then delete is also going to show a page or a form that will then be passed on to destroy, and destroy will actually do the destruction of the record. So now we have all of the CRUD actions in our controller. Let's just take a quick copy of those. We don't need to retype them. They're going to be the same. I'll just copy them. Let's jump over to our pages controller, and I'll just replace the ones that it generated with my new copied version. All right, I'll save both of those. I also want to point out that it did go into my config and routes file, and it went ahead and added all of these as well. I'll just make a space here so you can see them. So we have routes for these. We don't have routes for the actions that didn't have templates. You can go ahead and add those in here if you want, but in the next movie, we're going to talk about taking a different approach. In this movie, we're going to learn about a concept called REST and see how it leads us to resourceful routes. REST is short for Representational State Transfer. With REST, instead of performing procedures, we're going to be performing state transformations upon resources. Similar to what we saw in the last movie, this is about the way that we think about and structure our code. When we talked about CRUD, we talked about organizing our code into resources. So for example, we have subjects and we have pages. Each one of those then can have actions performed on it. That's what this means by state transformations. You have your subject's resource, you can add a new subject to it. That's a transformation of its state. Or we can edit an item that's in the resource. Again, another transformation of its state.
So when we talk about REST, what we're really talking about is using CRUD to structure our code well, and then thinking about the actions that we perform as transformations. REST further structures our code by adding some HTTP verbs. HTTP verbs are the way that we make requests from a browser to a web server. And you're probably familiar with the two most popular of those, which are GET and POST. GET is what you would use with links, and POST is typically used for forms. But REST expands on this a bit. GET is not just clicking on a link. It's when you're retrieving items from a resource. You're getting back information. POST is when you're creating a new item on the resource. You're putting something new there. You're posting it. Instead of using POST for all forms, though, it introduces two new verbs, patch and delete. Patch is for updating an item in the resource, and delete is for deleting one. We can see how these HTTP verbs line up against the actions that we were just working with in CRUD. You can see that index, show, new, edit, and delete all use the get HTTP verb. They're all getting back information from the resource. They may be getting back a list of all items, or getting back a single item, or getting back a single item and displaying it with a form so that we can edit it. But in every case, they're getting information. When we perform a create action, well, that's posting new information. It's processing the new form and it's posting information to the database. Patch is used for updating and delete is used for destroying. The combination of using CRUD with RESTful routes leads us to something called resourceful routes, and it is the Rails default. It's also used by most professional Rails developers. Now, you don't have to use it as a beginner, but because it's the default and it's so common, you do need to at least understand what it is. It is optimized for REST, and it gives you a very simple, consistent, organized structure, and it also improves your application security. The way it works is this. Instead of just having the simple routes that we've been working with so far, where it's just a string, now it's going to be a string combined with one of those HTTP verbs. So if the server gets in a GET request for subjects, it's going to display a list of all the items. But if it gets in a POST request for subjects, down in the fourth row, you'll notice that it creates an item. The URL string is the same in both cases, but it's combined with that HTTP verb so that the Rails application knows what to do with it. Notice also that the edit and delete actions have changed as well. Instead of the normal default route, which has the controller, action, and ID, now we have the name of the resource, the ID of the resource, and the action we want to perform on that item in the resource. So you may be thinking, that's a lot of routes that we've now got to define in our routes file to enable this behavior. But Rails makes it easy for us. We just go into the routes file and add resources and then the name of the resource. And all of those resourceful routes get added for us. Now, if you don't want to use all of those, which sometimes you won't want to, you can say to have a resource, but leave out certain actions by using except. Or if there are only a few that you want, you can use the only option. It's also possible to add resourceful routes if those don't all meet your needs. For example, delete is not included by default. When you call resources subjects, it does not provide a delete action. If you want that, you'll have to add one by adding a block that says member end, and then in between, define a get route for delete. Now the member is important there because it says that we're expecting to be working with a specific item in the resource. In this case, a single subject that we want to delete. If you want to do something to all of them as a whole, then you would use collection. So for example, if we wanted to export all of the subjects, we want to do it to the whole set, not to just a single subject, and so you use collection. It's really a way of telling it whether it should expect to receive an ID or not. In our web application, let's try adding these routes. I'm just going to take all of these that are right here, and I'm just going to comment them out so that they're still there if I ever want them. But instead, I'm going to use this resourceful route. Let me just move all these down too. I like to have the root up at the very top. So I'll just cut those. Let's put them right here before the default route. But then let's jump up here. Let's add resources, subjects, and resources pages. Now it's going to add all of those resourceful routes for us, but it's not going to add the delete route. If we do want that one, then we want to say do end and give it a block. And then inside that block, we're going to add another block, member do end, and any member route will go in here, such as get delete. And I'm just going to take all of this, copy it, and paste it after pages as well. So they both have that additional route added on. Once we've got it, let's save it and let's try it out. We'll type Rails S, that's short for Rails server. Once it boots up, let's open up Firefox and we'll go to localhost 3000/subjects. Now there's nothing on that page right now. We're just getting the default template view, but you can see that it's there. Let's now try subjects/new, and you'll see the new one. So those are both pretty easy. Let's go back and let's do subjects1. And now it loads up the show action, right? Even though I didn't write show here, I didn't say subjects show/1. Instead, I just said show1, and it knew it was the show action. Now, of course, it doesn't show anything right now. It's not going to find anything, but I just want to illustrate that it is a different way of formatting your routes. And if we did subjects1/edit, we'll get the edit page in the same way. If we use resourceful routes in our Rails projects, then all of the links and forms will need to use URLs that match those routes. Rails provides helper methods to make this process easier. You can write all of the URLs out the long way that we've seen before using a hash. You can specify the controller, the action, and the ID. But Rails takes advantage of the structure that we just saw working with resourceful routes and applies it to a series of helpers that make this process easier. For example, this same route can be written very simply as subject_path and then the ID that we want to pass in. Subject path is not the only helper, there are several. And each one of the helper methods corresponds to one of our CRUD actions. It may be daunting to just see a long list of them, but it makes a lot more sense when you understand the structure of how they're organized. First, notice that subject's path is the first helper. It's plural. Here we're working with the entire set of subjects, all the subjects in the resource. In the first case, we're using it paired with a GET request, such as a link, in order to show all of the subjects. In the second example, we're using it with a form, and when it's in that context, it'll be a POST request, which will post the information to create a new subject in the subjects table. It's the same helper method in both places, but the context matters. Notice also that subject_path ID is used 3 times. The first one is when it's a GET request, such as from a link, and that's going to allow us to examine the details of a particular subject. That's the show action. We can use that same helper method with the patch method, which would be assumed automatically if the context is a form, and that would allow us to update the information about an object. And then if we want to delete it, you could also use it in a form or a link, and you would just specify that the method that should be used with it is delete. Again, all 3 of those are the same helper method. It's the context that matters. And the remaining 3 are all different, but they follow a pattern. Notice that all 3 of them use subject_path, but at the front of them, they've appended on something additional: new, edit, or delete. I think it's helpful to think of that not as being the action, but being the format. So for example, if we call subject_path ID from a link, it's going to be the show action. But if we put edit in front of it, well, now we're still getting back information to the database. We're just displaying it to the user in a different format. We're going to display it to them as a web form suitable for them to update it. In one case, they're just seeing the information. In the second case, they're preparing to edit it. And the same is true for new and delete. With new, though, there's no ID because there is no existing record. It's an empty web form for an ID that doesn't exist yet. You'll be surprised how quickly you get used to these. These helpers can be just dropped in as the action on your links. So for example, link to all subjects, and the action is that helper, subjects_path. Notice that subjects is plural because we're looking at all subjects. Or we could have show subject using subject_path, singular, followed by the ID of the subject that we want to look at. Or we can have edit subject. It looks exactly the same as the show link, but it has that edit in front of it because now we're planning to edit it. Notice also that I'm not passing in the ID as an argument. I'm passing in the object itself. Rails is smart enough to know that if it receives an object instead of an ID, it should then ask for that object's ID. Let's try some of these out. Let's go into our application. We already have our routes defined. So let's go into the app and let's go into the views and let's start with demo. On the demo index, that's our home page. Let's put in a BR tag and then let's add our first link. Link to, and we're going to make it all subjects and then subjects plural path.
and then we'll close our link. That's it. That'll now be a link to our index action over here in subjects. So when that page comes up, it'll just show this basic text. Let's remove this placeholder text and put in a link instead. And I'm going to make mine link to, and this will be show subject. Now, normally this would be like a list of subjects that we'd be looking at. We'd be going to the database and retrieving the subjects. For now, we're not doing that. Let's just do subject underscore path, and we'll hard code in a 1. So again, normally this would be a link that's pulled dynamically from the database. We're just going to have subject path 1. When we click that link, that's going to take us to the show page. So let's edit that page. In fact, let's go back to the index page and let's copy our link here. Go back to the show page. Here we go. Paste it in. And now it's going to be edit subject. Oops, it looks like I had a plural on the other page. Let me just go back here. This should be show subject singular. Okay, so it's edit subject, and it's going to be the same, but it's going to have edit in front of it. So now we're asking to go get the subject again and display it to us on the edit page instead of on the show page. Now we could just leave this hard-coded as a 1 here, but let's take the additional step of going over here to our controller, and in the show action, that's where we are, let's go ahead and do a find. Subject equals subject.find, and we're going to get that from the params, so from params ID. So grab the params ID out of what came in from that resourceful route, find the subject in the database, set an instance variable to it, and now over here, instead of 1, we can just say @subject. We could do @subject.id, but it's not necessary. And most often, I think you'll see it left off. Once we've got that, let's try it out. Let's go over here to our console and start our Rails server, and we'll bring up Firefox. Now I'm on the home page already. Let's reload that page so that my new link appears, all subjects. When I click on it, it takes me to the subjects page. Now, normally this would be a list of subjects and I would pick one and click on it. Right now it's going to be just a single subject, which is subjects 1. So it added that up here. Now I'm on the show page, and it went out to the database and it actually did a query. You can see that right here in my log. It did a query. And now when I click edit subject, it got the ID from that object, and now I'm ready to edit it. So this would probably be a web form that would be ready for me to edit it. And then I would submit that to the update action, and we could use a URL helper for that as well. Hopefully you're starting to get a sense of how this is all glued together and how we can use resourceful routes effectively in our Rails application. In this chapter, we will implement the basics of CRUD in our controllers and views. We already have the routes and controllers in place. We're ready to set up the actions and view templates, beginning with the index action. Reading records from the database is usually handled by 2 standard Rails actions, index and show. Index displays a list of records, while show displays a detailed view for a single record. The 2 actions work together as a common application design pattern. The application displays a list of items, the user clicks a link for one of those items, then the application shows the user a detail page for that item. After the user reviews those details, the user then clicks a link to go back to the main list. Even if you've never put these exact terms to it before, I'm sure you're familiar with this concept from other websites. Let's see how we can add the index action to our subjects controller. Let's begin by going into our subjects controller, and you can see that we have a placeholder for our index action, but it doesn't contain any code yet. So we have to ask ourselves, what do we want this action to do? We want it to get things set up for the template. So we want it to go to the database, retrieve a list of all the subjects that it should display so they can be available for the template to list them. So let's set an instance variable, subjects, and let's set it equal to a query to the subject class. We can use .all if we want all subjects, or I think even better is to order them by their position, ascending. You don't have to put all after it, it's assumed. Now we have an instance variable that's set to whatever the database has for all subjects, and that'll be available to our template. We could specify the template that we want to use here, but because our template is going to also be called index, we don't need to. So that's it. We've set everything up that this template will need. Let's go find the template. Inside the app directory, inside views, inside subjects, we have index.html.erb. Now we need to add the HTML that will make this display a list of the subjects. Rather than have you watch me type all this out, I've actually included in the exercise files some HTML that we can use. So I'm just going to copy this, And then let's switch over to index again. Before we paste in, just notice the action that we were passing in to this link here, because we're going to want to use that again. So let's select everything and paste in the new HTML. Let's walk through it together. So there's a div up here at the top and an H2, so it'll say subjects at the top. There's a link that's going to be for adding a new subject. There's just a placeholder there for now, but we'll get to that later. Then there's the listing. This is going to be a table, and you can see the header is going to just have a number. That's going to be the position. Then we have subject, the name of the subject, visible, pages, and action. And then below each of those, we're going to go through each of the subjects using subjects.each. Each time through, each one of those items is going to be subject. It's going to be an object called subject. And on that object, we can ask for its position. We can ask for its name. We can ask whether it's visible. We can ask for its pages and the size of those pages. And you may notice that this is a piece of Ruby here. It's called a ternary operator, where if this part is true, then it will do this. And if it's not true, it will do this. It's just a shorthand one-line if-else statement. And then I've got a set of actions. So we're going to eventually fill these in. We have show, edit, and delete. Okay, now that we have the HTML for this, let's try it out. I'm going to save this page. I can close up the paste into index page. And let's come back over here and launch the Rails server. And then when that's listening, we'll go into Firefox. And instead of subjects1, let's take all this away. The URL is just subjects. We're going to ask it to return a list of subjects. And it did. You can see over here that it actually went out and it queried for the subjects ordered by their position. And then it displayed, oops, let me go back to the Firefox here. Let me move that window a little bit. And now you can see that it lists each one out. So it goes through each subject and it has a line for the first subject and a line for the second subject. We're now successfully reading a list of the subjects from the database, creating objects from them and making those available to the view template, and the template is displaying them as a list. Next, let's talk about how we implement the show action. In this movie, we will learn how to implement the show action, which is the other common read action used for CRUD. We already learned how to use index to return a list of records. Now we want to use show to look at details about a particular record. One key difference about show is it's going to require an ID, and that ID must exist in the database. If it doesn't, Rails is going to return a record not found error. So we're going to use that ID to tell it which record we want to see the details of. Before we start coding the show action, let's create a link that'll get us to it. So from the index page, what we want is for this show link to take us to a detail view for subject with ID 1, and this one to have a link that takes us to details about subject 2. The placeholder for that link is down here, and we just have a placeholder action now. We want to replace that with a proper target. You could use a string. For example, it could just say subject / and then the ID we want, or we could use a hash. You could have action. It's going to be show, and the ID is going to be subject.id. If you've decided to use resourceful routes, which I encourage you to do, you can just use subject_path and then pass in the subject object itself. You can also pass in .id, but it'll extract that ID for you. Any of those three methods will work, but I'm going to be using those resourceful routes. Once we have that, we can save it. We won't bring it up in a web browser just yet. Instead, let's switch over to the subjects controller and take a look at the show action. I've already got some code in there that I put in the last chapter. Let's look at what it's doing. The show action's job in the controller is to get everything ready for the template. So what is the template going to do? It's going to show details about the subject. So the controller needs to go to the database and find that record. It does. It uses subject.find in order to find a record with the right ID, and it assigns it to an instance variable so that the template can access it. Notice the way that we're getting that ID is by using params. We're asking the params to give us back the ID that was passed in the URL. It'll extract it for us, and we can use it to find the record in the database. We don't need to specify the template because we're going to be using the same template named as the action. If we scroll down and find that template, you see we just have a placeholder here right now. I've also included a file in the exercise files that has some HTML we can use. I'm just going to copy that, and then we'll go into that show page. It disappeared on me. There we go. I'll paste that in there. We'll save the page. Let's walk through and look at what it does. At the top, we have a link that is a back to list link. And where does it take us? It takes us back to that index page. And we're using that resourceful helper subject's path to get us back there. Then we have details about the subject. So it's just a table with the details. Here's the name, and then we ask for subject.name. So here we're using that instance variable, and that's an object, so we're calling name on it. Then we're doing the same thing for position, for visible, created at, and updated at. Let's try it all out. Let's save that page. Let's make sure our web browser is running. Once it is, we'll switch to Firefox. I'm going to start by reloading this page so that I now have the correct links. And when I click on show, you'll see it takes me to subject/1. And now I'm on the show subject page. And here's details. Initial subject, here's its position, whether it's visible, and the date it was created at. Now I have a back to list link. I can click on that one. Now I'm on the index page again, and I can click on the second show, and I can see details about the second subject. Notice now the URL is subject/2, and I'm seeing a different set of details. And then I can click back to list. And you can imagine using the same design pattern, whether you're looking at products or customers or anything else that your web application might want to display. We've successfully added pages to allow users to read database data. Before we can add the create, update, and delete actions to our controllers, we need to learn about using forms in Ruby on Rails. There are a couple of points that I want you to remember before we dive in. The first is that anything that we can write with our Ruby on Rails helpers can also be written using simple HTML. That's all the helpers are doing. They're helping us to write HTML code. And the end result that gets sent back to the browser is always just plain HTML. But the second point is that writing code using the helpers is almost always easier, more powerful, and has lots of extra benefits than using simple HTML alone. Let's first begin by just looking at a standard HTML form. Again, this is not Ruby on Rails, just basic HTML. Notice that my form has 3 text input fields for name, position, and visible, followed by a submit button labeled create subject. Notice this form is going to use the method post. That's different from when we click on a link or a URL. Links and URLs are GET requests, forms are POST requests. And remember, the method's important when we're using REST to route our requests. You'll also notice that the form has an action that is just /subjects. Our routing will direct a POST request to that URL, to the subject's controller, and to the create action. The POST parameters in the controller are going to be accessed in the same way that we access GET parameters, like we did ID in the last movie. We just say params and then the key we want. Here I'm getting name, position, and visible. This is different from other languages like PHP, which separate out GET and POST parameters. In Ruby on Rails, they're combined together. If we want to use those parameters to construct a new subject, we could put each one into a hash and then pass them into subject.new. This is the simplest way to work with forms in Rails. But there are improvements that we can make. The first improvement is that it's tedious to build up a hash by grabbing each parameter by name. Imagine if we had a form that had 40 fields in it. It's much better if we can do that using form arrays. Now, form arrays are also just a basic part of HTML. It's not special to Ruby on Rails. In this version of the HTML form, notice that the name value for each of these inputs has changed. Where before, the value was just name, position, and visible, now it is subject, followed by, in square brackets, name, position, and visible. When you use this HTML syntax, these values are submitted as a group in an array named subject. And we can access those values as a group as well. Of course, we can look at them individually by doing params and then subject, followed by name. That's saying go get the subject value, and then from that array, pull back the name value. But we also can just say param subject, and we'll get back a hash of all those values. Params does that for us. That's handy because then we can just drop that whole set of parameters into one of these methods. To make this code actually work, we'll need to learn about strong parameters, which we'll do soon. But for now, let's just notice how you can drop a whole set of parameters into a method. Up until this point, our forms have just been made up of pure HTML, no Ruby on Rails helpers at all. Let's look at that nested parameters version that we just saw. I'm now going to show you a version that uses Rails helpers. Remember that you can scrub back and forth in the video if you want to compare them. In this version, I'm using the Rails Form4 helper, and that Form4 helper accepts an object as an argument, and I'm passing in my subject object. That's the instance variable that I've set in the controller. That's followed by a code block, everything from do to end, and the F is going to be a special object for this form, and I can build things onto that form object. So f.textfields adds a text field to the form. This one's going to be a text field for name, and then I have one for position and one for visible. And there's other variations on that. You can have text areas, you can have checkboxes, you can have radio buttons. There are helpers for each one of them. For now, we're going to keep it simple and just stick with text fields. So these helpers are going to help us generate the HTML that we need. What's going to be output is still just basic HTML, but this gives us some benefits. First, the Form4 object knows whether the object is saved or not. If it's a saved object, then it knows we want to do an update action on it. And if it's not a saved object, it knows it's going to be a new or create action. It adjusts the form accordingly for us. Also, if it's an existing object, it knows to pre-populate all of those text fields with the existing values. Our other HTML versions didn't do that. We would have had to write code that would drop in the existing values. There are many variations on these forms, and there's lots of other helpers that you can explore. But let's apply these basics so that we can create forms for our create, update, and delete actions. Now that we understand form basics, we're ready to implement the create actions in our controller. The create part of CRUD is made up of two standard actions, new and create, and they work together. The new action displays a web form that a user can fill out and submit to the create action. The create action handles the form processing and submits the record to the database. Let's focus on the new action in this movie. Let's begin by adding a link in the index template to take us to that new action. So here on the index.html.erb template, you can see I have a placeholder for add new subject. I want to change this action. You can make it a string, a hash, or you can use the RESTful route URL helper. That's what I'm going to do here. The route helper is going to be called new_subject_path. Notice that it's singular because I'm still talking about one subject. I'm creating one new subject. And I don't need to have any kind of an ID or anything after it because there's nothing that exists in the database yet. So this will create a URL, and when the user clicks on that URL, it'll be routed to the subject's new action. You can see I already have a placeholder for that. What code do we want the new action to perform? You can leave nothing there at all. And if it gets to the form and it's blank, it'll know to display a blank form. But I'm going to recommend that we go ahead and put something here anyway. Let's go ahead and create a subject, and the subject is going to be an instance of the class that we want the form to be for. So why do it this way? There's two reasons. The first is that the database may have default values that get set. For example, you might have a Boolean that defaults to being false. And this would pick up on that. It would make sure that then your form displayed that attribute as being false by default. And the second reason is that we can set those ourselves. So for example, if you wanted to set visible equal to false by default, I can set that here in this new object. Now this is an unsaved object. It's not saved to the database this way. This is deciding what this object is going to look like that's used to display the form. And if we don't want to set any of those things, then we can just create the new object like this. Once we have that and we've set it equal to this instance variable for subject, then we're ready to go to the new template and render that form. Rather than have you watch me type all that in, I'm going to go into the exercise files and get some code that's provided there. You can pause the movie if you need to copy it down, or you can get it from the exercise files. And this is going to be some HTML we can use for our new template. Notice at the top is a link to take us back to the list, back to subject's path. That's the index page. And then we've got the form using Rails helpers. So it's form4. You can see that it's creating a block. Down here, we're setting text field, and text field for each one of those. We've got a submit button at the bottom. Now notice when I have form4, it's a form for a subject. So I'm passing in that subject object to it. I could just do that. That would be enough on its own. Ruby on Rails would look at that subject and be able to tell that it's not saved to the database. So it knows that the URL is going to be the URL used to add a subject to the database, the create URL. And it knows that the method for that's going to be post. I'm just writing them out explicitly. If you don't want to let Rails do the defaults, you can also specify it. So that's what I'm doing here. Notice the URL is subject's path. When it's post, it's going to be create. Up here, subject's path was also the helper, but it was a GET request because it's a link. So it takes you somewhere different. That's where it makes use of those RESTful verbs. Once we have that, let's save it and let's try it out. Let's make sure that our server is running. And when it's listening, we'll just reload this page. Oops, 1 second. There it goes. Add new subject. Now when we click on that, it takes us to subject/new. We see a form for create subject, and we have a create subject button here that'll let us click it, and we'll send data to the create action. We also have back to list, which will take us back here as well. Now we've used our form helpers to create a form so that we're ready to submit data to the create action. Let's look at that next. In this movie, we will write the create action and learn to process form values. In the previous movie, we added the new action. New and create work together as a pair, and together they make up the create portion of CRUD. New displays the form, create processes the form. Let's look at the four main steps in form processing. First, we need to instantiate a new object using the form parameters. Then we attempt to save that object. If the save succeeds, we're going to redirect the user somewhere. In our case, we're going to redirect them to the index action. If the save fails, then we want to redisplay the form to allow the user to fix the problems and resubmit it. You might be wondering, how could a save fail? Well, we haven't put any data validation into our application yet, but eventually we would. Data validation ensures that the data being received matches the criteria we want to allow. For example, we might want to limit the subject's name to be a maximum of 50 characters. And if it's not, we would raise an error. Even though we won't be adding data validation, we will include this step now because it's an essential part of the way forms are processed in the controller. So we already have our new form, and it's going to submit to the create action. So let's go to subjects controller, and here's our create action. And to begin with, I'm going to paste in those 4 steps so that we can work with each one of them. First, we want to instantiate a new object using form parameters. Well, we know how to do that. We're going to create a new object. It's going to be subject, and we will use subject.new, and then we can pass in the parameters to it. And there's a number of different ways we can do that. I'm going to use params:subject because I do have all of those grouped by subject here when I use these form helpers. That's going to be automatically there. In fact, we can take a look here at the source code, and you can see if it'll show me. It's kind of small here. There it is, name, subject, and then in square brackets, name. So because those are going to be an array, then I can just drop all of those in using params. Okay, so I've instantiated it. Now I need to try to save it. All right, at subject.save. Now I need to check and see whether the save succeeded or not. Well, save will return true or false, so I can make it part of an if-else statement. So if subject save, if it's true, then it succeeds. Else, it failed. And so if save succeeds, what do we want to do? We want to redirect to, and where do we want to redirect it to? We want to send it back to the index page. Do you remember the helper to use for that? Subject's path. So it'll redirect to the subject's path. If it fails, we want to redisplay the form. We don't redirect to get there. We just need to render the form. So we're going to render the new form. Note that when we call render new, it is not doing the code that is inside the new action. We could do that if we wanted to add a line here that said new. Now it would actually call that method up here. It would do everything that's in here. But if we don't on its own, it's just going to render the template based on what's already been done inside this action. Now, in this case, that's not a problem because in new, we were setting up an instance variable called subject, and in create, we also have an instance variable called subject. But if our form was expecting to have other values set, for example, maybe there was something that said like maximum count or something, and we were setting that value, we would also need to make sure that we set that value here before we do the render, because the template may be expecting to have certain instance variables. So just be careful about that. Make sure that any instance variable the template needs is still set up inside this create action. Don't depend on it being up here in the new action because that action doesn't get called. One nice thing about rendering the template with this subject that we already have is that the default values when we go back to render that form are going to be the current values that were submitted. The user isn't going to have to retype them, and that's nice. Let's try it out. Let's save this page. Let's go back over and we'll make sure our web server is running. If yours is still running, that's fine. And then we'll open up Firefox. Now I'm on the new page already. I don't need to reload it or anything. Everything's fine there. Let's fill in the form fields with test, subject, and for the position, I'll make it 3, and visible, I'll type in false. You might want to use checkboxes or radio buttons instead. For now, we're just going to keep it simple with text fields. Now let's click Create Subject. Create Subject sent it to the create action, and it did start to do the code there. But we ran into a problem. The problem is forbidden attributes error, and we need to stop and talk about what this is so we understand why it didn't work and how we can fix it so that it works. We'll do that in the next movie. In the last movie, we tried to submit a web form to have it processed by our create action, but we got back an error. But that's okay because the error that we ran into was actually a Rails security feature that's very useful, but we need to learn how to use it. And to do that, we have to learn about mass assignment and strong parameters. Mass assignment is the term for passing a hash of values, usually from form parameters, to an object that's going to be assigned to the object's attributes. New, create, and update are the primary methods that use mass assignment, but there are a few others as well. In each one of these cases, you'll see that we're taking a hash of values and we're essentially just dumping them into the object and asking the object to assign all of the attributes based on that hash. That's what mass assignment is. Rails is making our lives much easier by allowing us to assign values to this object all at once instead of having to assign them one by one. Unfortunately, this convenience also introduces a major security issue. Imagine that we have a form which lets users update some information, like their first name and last name. Now imagine that a hacker figures out a way to submit a fake version of the form, and on that fake form, the hacker includes some extra fields that then show up as form parameters. Rails will dutifully grab all those attributes and mass assign them to the object before it updates the database. In this example, our imaginary hacker was able to change the user's password. Instead, we need a way that we can filter the attributes which are being allowed to be mass assigned so that we allow only the attributes we intend. That's where strong parameters come in. By default, Rails will not allow you to mass assign your parameters to one of your objects. Instead, we have to tell the objects what's permitted. So for on params, you would call permit and then tell it what attributes are available for mass assignment. It's a way of marking them as being allowed. There's another method that we can also use on our params that's called require, and require ensures that the parameter is sent. Require doesn't actually do any permitting, but it raises an error if the value's not there, and very helpfully, it returns back that hash so that we can work with it. So if you combine the two together, you get something like this. Params require subject, which will then extract the hash from the subject params, and then mark as permitted name, position, and visible. That sets up the allow list. And any other parameters that aren't in our allow list can still be accessed one by one, but they can't be used for mass assignment. Let's see how we can fix this problem. Let's go over to our controller, and instead of doing the mass assignment that we're doing here, what we instead want to do is we want to take our params, we want to say that we want to require the subject, and then we want to permit, and what do we want to permit? Well, we want to permit name and visible and position. Anything else is still going to be in the params. We can still access it directly, but it's not permitted for mass assignment. So that'll mark them correctly. Now let's also be mindful that we're going to need to do this eventually on our update action as well, because we want to also allow certain parameters. Because it happens in both places, the pattern that's most often used is that you take that whole permission string and you come down to the bottom of your model and you set a private method that we're going to call subject params. And then we'll paste that code inside of there. So now subject params does all of this for us. So let's take subject params, let's pop back up here. And instead of mass assigning the raw params, we're now going to call the subject params version. So this has the effect of calling this method down here, which does the requiring and permitting. And we'll be able to reuse this once we get to our update action. Let's save all this. Let's go back and see if that fixed our problem. I'll hit the back arrow. Our form is still filled out. Let's hit create subject. Now that we've permitted parameters, our create works successfully. You can see that we have a new test subject created here as our third subject. Let's remind ourselves what happened here. We submitted from the new form to the create action. Those parameters We required and permitted so that they were allowed to be used for mass assignment, and we could just drop all of them at once into the new action. We instantiated the new subject, then we tried to save it. The save succeeded, so it redirected to the subject's path. If it had failed for any reason, it would have re-rendered the new page, and the user would have had the opportunity to fix any mistakes and try again. In this movie, we will add the ability to update existing records. Like create, there are two standard Rails actions for updating. Edit displays the form, and update processes the form. It's very similar to the two-step process we used for creating records. There are two key differences though. The first is that we need to make sure that we have an ID. New and create didn't need an ID because there was no record in the database yet. But edit and update require an ID so they can find that existing record. The second difference is going to be in the way that we do the form processing. Create instantiated a new object and then saved it. Update is going to find an existing object and then call the update method to update the record in the database. You'll also notice that it's very common for the form fields on the two forms to be very similar. And that makes sense. If we're asking a user to do data entry to create a record, then we probably want to offer those same form fields to them when they're editing a record. Let's begin by going to our index page, and let's edit that placeholder for edit so that it will take us to the form page for edit. Now you could put in a string or a hash, but I'm going to use that helper method with the RESTful routes, and it's edit subject path, and then subject is going to be passed in. Notice that it's very similar to what we had for show. The only difference is that edit is being prepended onto the front of it. This helper method will generate a URL that will then be routed to the subject's controller and to the edit action. And you see I have a placeholder for that. So what does the edit action need to do? It needs to go and find that existing record and make it available for the form to be able to display those values inside the form for editing. So how do we find a record? Well, we did it up here for show. And it makes sense. Edit and show are very similar. Both of them are finding a record in the database and displaying it to the user. They're just displaying it in two different contexts. One of them is a detail view and the other one is a form. Let's save the controller and then let's go look at that form. It's going to be in edit.html.erb. And instead of this placeholder, what we're going to have is a form that's very similar to what we had for new. So let's copy everything that's in the new action and let's paste it into edit as our starting point. Let's go through it and see what needs to change. We're still going to have this back to list link that'll take us back to the listing. Instead of subjects new, let's make it subjects edit. And let's change the text to update subject. And the button down here also will say update subject. The form fields, as I mentioned, are going to be the same for both of them. In both cases, you can create a new record with the name, position, and visible, or you can edit those same attributes, name, position, and visible. The form action, though, is going to be a little different. On the new form, we specified the URL and the method was post, but those are optional. We didn't have to do that. And here we don't want them because they are specific to the new form. Instead, we would need to change those to a different URL and the method should be patch when we're doing an update. Instead, I'll just remove them and let Rails handle that for me. Rails knows that the subject already exists in the database, so it knows that this is an update and it creates the right URL and uses the patch method to submit it. Let's save this form and let's try it out. I'm going to launch our server. And once it's running, we'll go into Firefox. Let's just reload our subjects page so we get a link. You can see that it took me to the edit action. The page is now different. It says update subject. We're seeing those same form fields right here. Now I also want to just use the inspect element option here to take a look at the HTML that's being generated. If you scroll up here to where the form is actually being created, here's the form. Notice that the method is listed as being post, but I just got through telling you that it doesn't use post, it uses patch. Notice that there's a hidden input here whose value is patch. So it has the post method here, but it has another method hiding as a hidden input field. The reason why is that post is widely supported on the internet where patch still is not. So this is the way that Ruby on Rails works around it. When a post request comes in and it has this hidden method name of patch, it knows to treat it as a patch request. All right, let's close up the inspector now. Now we can't submit the form yet because we don't have our update action. So let's go to the subject's controller and let's add that action. So down here in update, what do we want to do? Well, the first thing we want to do is we want to find the relevant subject. So I'm going to do the exact same step here. I'm going to find that same subject based on its ID. And then I know that I want to update what it has using the update method. And what do I want to update it with? I want to use the form parameters. And we learned about strong parameters before, and we know that we want to use this version where we've permitted certain values to be used. So I'm going to use subject params again inside update. Now, if it succeeds, we want to take one action, and if it fails, we want to take a different one. So we also can use the fact that it returns true or false to make it part of a conditional statement. And if it does update successfully, we want to redirect to, and we did a redirect before to the index page, but I think now we want to go to the show page where we can see the detail view instead of going back to the full list. So let's make this subject path, and then at subject will be the argument. And if it fails, then we want to render the form again. This time the form is the edit form, not the new form. And again, it doesn't perform this edit action. It's just going to render that template, but that's okay. We have an instance variable of the subject with all of the new updated values that'll get redisplayed. So it won't be the database values. It'll be whatever the user just gave us. We're going to show them their data again and let them fix it. Okay, now that we have all that, let's try it out. Let's save the controller. We'll come back here. This is already going to submit to the right place. So let's change it so that visible is going to be true. Update subject. Look at that. It changed it. Sent me to the show page. It says visible true. If I click back to list, let's edit it again. This time, let's change the position equal to 4. Update the subject, change the position equal to 4. We now know how to use our controllers and views to both create and update records in the database. In this movie, I want to introduce you to partials and helpers. Partials and helpers are important for having good code organization in your Ruby on Rails project. And most importantly, they help you to not repeat yourself. And remember, that's one of the fundamental mantras, dry. Don't repeat yourself. Partials are going to be partial templates, and we want to create partial templates that we can share between a number of other templates. Helpers are methods that can be called in the view templates, so we can move Ruby code into those helpers and call on it when needed. In the last movie, you may have noticed that our new form and our edit form have a lot of code in common, especially this table of form fields. What I want to do now is use a partial so that they can share that same information and we won't have to repeat it anymore. The convention for doing that is to create a new file inside the subjects, and we're going to call it _form.html.erb. The underscore is the standard way of letting Ruby know that this is a partial template. It's not a full template, it's a partial. And what we want to put in there is the code that we want to share. So I'm going to take everything from table all the way down to here, and let's cut that. Let's come over to the form, and let's paste all of that in there. So let's save it, and then let's come back to new. And now since the form is gone, we need to tell it to load up that partial. So we're going to use render to do that. We've seen render before, but this time we're going to tell it to render a partial, and then the name of the partial. We're not going to use the underscore in front of it here, just the name without the underscore. Ruby on Rails knows because we called it a partial that it needs to add the underscore. And then we also need to tell it one more thing. If we look at the form partial, it has a variable here, f. Now it's not going to know what f is when we load in that partial. If it had an instance variable, it would have access to any instance variables, but this is a local variable. And it's not going to know what it means. So we have to also add something here that says locals, and then provided a list of the local variables it needs. So it's going to need f, so we'll use the symbol for f, and then what is f equal to? Well, f is this f right here, this variable that we were working with. So we're essentially telling it that f on the partial is equal to the same f that's on the main template. We can copy that line, and then let's save it. We'll jump over to the edit form, and now all of this can also be replaced by that same render. So in both cases, they're going to render the form that's here, and it's going to be a shared partial then between them. Let's fire up our web server and you'll see it. Rails S, bring up Firefox, go back to list. Let's click on new subject first, and you see the form is here. Click back to list, and we'll click on edit, and you'll see that it also renders the form, and this time it populates it with values. This is a great way to not repeat yourself in your code, and forms is one of the best places you can do it. Now, if your forms were different, you don't have to share this data between them. But if it's the same, this is very convenient because now if I make changes to the form, maybe I change one of them from a
text field to a checkbox, or maybe I add more attributes that can be edited. I can do it in one place and it'll show up on both forms. Helpers are another good way to clean up your code. There's a whole folder here called helpers. These are view helpers. They're there to help you with your views. And you have one for subjects. That's helpers that are unique to the subject's controller. And you have one for pages and demo. And then we have application helper. And that's where we put things that we want to use throughout our application. So I'm going to add a new one here. I'm going to call it error messages. I'm writing Ruby code for object. And inside it, I'm going to do a render. I'm going to render a partial. And the partial, I'm going to put in a folder called application that doesn't exist yet. And it's going to be called error messages. And we're going to pass in some locals to it. I'm going to pass in object is equal to object. So that's whatever gets passed in here essentially gets passed to the partial as well. So now this is a helper method. This is a method that I can call from anywhere inside my application, and it will do this rendering for me. Now, why am I doing that? Well, one of the things we don't have in our application yet is a way to show error messages on the form. So that's what we're going to do. We're going to use a helper method and a partial to achieve that. I'll save this helper, and then I'm going to come down here to the views. Actually, let me go to the desktop here. And inside my simple CMS, inside the app, inside views, I'm going to add a new folder. Didn't go in the right place, but that's okay. I can drag it. It's going to be called application, and I will drag it in there. There's no limit to what folders we can have in the views. They don't have to all match up with controllers. Most of them do, but I've added a new one called application. And in the exercise files, I've got error messages html.erb. I'm going to drag that in there, and then we can go take a look at it. So let's go back to the code. Here's application. And here is that new partial template. Notice it has underscore at the beginning of it. And it says if the object, the local variable we passed in, if it has errors greater than 0, then display some text saying, hey, there were some errors that kept this record from being saved, and here are the problems. Object maintains a list of the errors. When it tries to save it, Rails reports back on what the problems were that prevented it from being saved. And this allows us to access that. We can ask for the full messages and just iterate through showing them all in a row. So now we have a helper method that will call that template for us, but we also need to use it. So I'm just going to copy this. And where can we put it? Well, let's put it on the form. That way it'll show up on both new and edit, which is what a partial is good for. So right here, I will say error messages for, but I don't want object. It's going to be error messages for f.object. This form knows what its object is, and it keeps track of it with object. So it just happens to be the same name. So asking the form for its object, which in this case is the subject, is then going to call that helper method. The helper method will then render that template, and we'll see the error messages appear right above the form. Partials and helpers play an important part in keeping your code organized. We've now learned how to read, create, and update records. The remaining CRUD action is delete. Delete is also made up of two different actions, delete and destroy. Delete would display a delete record form, and destroy would actually do the destruction of the record in the database. Notice that the RESTful route for destroy is going to use delete as its verb. There are a few other points we need to keep in mind. Delete and destroy are going to require an ID to be sent so that they can find an existing record. And that just makes sense. You can't delete a record if it doesn't exist in the database. Delete is going to use find to find the record, and destroy will use find and destroy. Now it can get confusing because the HTTP verb that we're using for destroy is called delete, and there's also a Rails method called delete that we can call in the object as well. But we want to make sure we're using destroy when we're actually doing the destruction. So it's worth considering whether a delete form is actually necessary. It's a good place to put confirmation before you delete something, to include any warnings that you want to give the user, or to display record attributes, to say, hey, you're about to delete a record that has these properties. Are you sure you want to proceed? Often the delete form is omitted, and the user can go directly to destruction. Sometimes that link to destruction will include some JavaScript that might pop up with a confirmation instead of having a full page. In fact, when we use our resourceful routes, the delete action is not created by default, only destroy. We had to add a route for delete in order to make it work. It's really a matter of style and personal preference.
To start with, let's go to the index page because that's where we've got this placeholder for a link for our delete action. We could have this go directly to the destroy action. For example, we could have subject underscore path, pass in the subject, and then we could include the method as being delete. And if we do that, then this link will send the delete method along with this path, and that'll go straight to the destroy action, and it'll destroy it. We could also add some JavaScript on this link so that a confirmation would pop up and say, are you sure? So the user could be alerted. I'm not going to do that though. Instead, let's take this out, the method. It's going to be a regular GET request, and we're going to request the delete subject path page. You'll remember we added that into our routes. So that will then generate a route that will take the user to this delete action here. And what is the delete action going to do? Well, it's just going to display a warning to the user to say, are you sure you want to delete? So I'm going to just take the subject find and paste it in there because that's what it's got to do. It's got to find the subject so that we can display information about it for the user. Let's go to that delete template, and let's also open up the new template and copy that because we're going to create a form on this page. You could do it with a link, but we're going to do it with a form, and it's going to say delete subject. Let's change this up here to say delete. And this will also say delete subject. But instead of having this render the form fields, let's take those out. And instead, let's put in some paragraph tags and we'll put in some warning text here. Are you sure you want to permanently delete this subject? And then below it, we'll put some more paragraph tags and we'll put the actual subject, subject.name. And that way they can sort of see it and think about it before they commit to actually deleting it. All right, now we have to look at the form action. It's form for subject, that's fine, but this URL is all wrong. The method is not going to be post, the method is going to be delete, and we can actually just take this URL out and it'll default to the correct thing because a form for the subject with the method delete is going to go to that destroy action. All right, let's save that form. And now let's go to our controller and let's think about what this destroy action ought to look like. It also has to find the subject. We have to know it's in the database, and we know how to destroy by just calling destroy on it. Don't call delete, call destroy. Now you could make this part of a conditional statement if it's destroyed successfully or not, similar to what we did up here when we were checking for update and we did when we were creating. However, when we're adding or updating data to the database, there's more chances that the data doesn't conform to our expectations and we need to reject it for some reason. When we're destroying it, that's not the case. When we're destroying it, if the record's there, we just get rid of it. There's really not a lot that can go wrong. So most of the time you don't need to have a conditional here. Instead, we can just do a redirect. We can't redirect back to the record because it's gone. So let's go back to the list. That's going to be subjects underscore path. All right, let's try it out. Let's go over here and launch our web server. And once it's running, let's reload this page so that now we get our delete link. When I click on delete, it takes me to subject/4/delete. That's my delete form. Are you sure you want to permanently delete this subject? Here's the name of the subject. And if I click this link, it destroyed it and you can see that it's gone. It's no longer in the list. We can look at the SQL that it created in the console and see right here that it's deleting the subject with ID equal to 4. If you go back to the subject's index page in your browser, there's now 4 main links, and each one of them represents part of CRUD. We know how to create, read, update, and delete the records that are in our database. It's time for a challenge assignment. This challenge will give you the opportunity to use everything we've learned in this chapter. Your objective is going to be to create the CRUD for pages, the same create, read, update, and delete processes that we just created for subjects you're now going to do on your own for pages. You want to make sure that you have routes defined. Those routes should point to controller actions. You should have index, show, new, create, edit, update, delete, and destroy. Try writing those actions without peeking at the subject's controller. Try to remember what each one of those actions ought to do and write the code for it. And you can always look at the subject's controller if you get stuck or if you want to double check your work. You'll also want to create templates for those actions. For those, you can copy the HTML that was used in the subjects and modify it to work with the new controllers and actions. When it comes time to create forms for the pages, go back and review the database schema to see what the model attributes were. What form fields should you add? They won't be the same. And you can go ahead and just use text field for all of the form fields. This challenge will take you some time to complete, but it gives you an opportunity to use everything that we've learned about Ruby on Rails so far. Once you've got the CRUD working, in the next movie, I'll show you the solution that I came up with. Hopefully you had success with this challenge assignment. In this movie, I'll show you the solution that I came up with. The first thing that I did was I went to the routes file, because that's where everything starts in our Rails application. Requests come in and we have to be able to route them correctly. I had a resourceful route already set for pages, and it included a member route for delete. So that has everything that I need, so I knew I was in good shape. The next thing I did was I went to the pages controller, and I had placeholders for all of the actions, but I needed to fill them out with the actual code that each action would perform. So I went through them one at a time. For index, I knew that I needed to come up with a list of pages that we could display as a list. For show, I needed to find a particular page based on the ID that was passed in params. For new, I wanted to display a web form, so I set page equal to page.new, and that just gives me a blank instance that has whatever database and model defaults might come along with it. And then I have the create action. It's very similar to what we did for subjects. It's going to create a new page based on the parameters that have been sent in. And page params is a method down here. It's a private method. And you can see that params is requiring page and it's permitting values. And it's permitting a few more than subjects did. Not only does it have name, visible, and position, but it also has permalink, content, and subject underscore ID. That's that foreign key that's going to relate a page to a subject. We need that too. So then if we scroll back up here to create, we have a conditional. If it saves successfully, we're going to redirect back to the list of pages. If not, we're going to redisplay the new form. Edit is going to display a form to allow us to edit content. So we need to go out and retrieve that data from the database so we can edit it. Then update will perform an update. Works very similar to create. It uses page params and passes them into update. If it succeeds, it will redirect back to the show action for each page. If it doesn't, then it'll re-render the form again. And delete will just find the page to make sure that we want to delete it. Destroy will find the page and then destroy it and redirect back to the pages path. Once I had my controller complete, then I went to each of the views and tried to get those sorted out. The first one was index.html.erb, and it's pretty much the same as what we had. You can copy it over from subjects. You mostly are just replacing the word subject with the word page over and over again. The only difference was that I went ahead and added a column here for subject, and I took away the column that used to say how many pages belong to a subject. So here you can see I have page position, and then I have page.subject.name. So I'm getting a page, I'm finding its subject, and getting that subject's name. Then I have page name, I have visible, and then I have my actions. I have show, edit, and delete. Next, I went to the show page and I made sure that I added in those new attributes that we want to display. So I have subject name up here, I have permalink, and down here I have content. The other ones are pretty much the same. For new, edit, and delete, it was really just a matter of changing the word subject to page. On the form though, I wanted to add those extra attributes. So I've got subject ID, I've got permalink, and then I went ahead and used text area. I told you in the objectives to use text field for everything, but I went ahead and slipped one in here. Text underscore area will just give us a bigger content box. It'll be 10 rows by 60 columns. And that'll give me some room to edit paragraphs of page content. With all that in place, we can try it out. I have my web server already running, so let's go to the web browser. Let's go, instead of subjects, we're going to start with pages. So here we are on the pages, and we can add a new page. So let's add a new page. We'll add it to subject ID 2. We'll call this test page. And we can give it a permalink if we want. We'll give it a position of 1, visible true, and content. This is a test. Now let's create the page. There it is. It worked successfully. Here's our test page. We gave it a position of 1, so it got sorted right after this one here. If we want to go to edit now and change its position to 3, We can also see how edit works. It worked successfully. It took us to the show page. So we see that it did do it successfully. We see all those things showing up on the show page. Back to list. Now here it is. We see our test page. It belongs to next subject. And we can finally click delete to try deleting it. And it's gone. We now have all of the code and web pages we need to create, read, update, and delete records that are in our pages table. Thank you for taking Ruby on Rails 6 Essential Training with me. We've learned the fundamentals of using the Ruby on Rails web framework, and we used our new skills to build pages that interact with the database to create, read, update, and delete records. The pages that we built are the standard CRUD pages, the patterns that are going to be used the most often. But these are not the only pages that you will use when building web applications. However, the same principles that we've learned for these pages will apply to any page. And of course, our simple content management system is still very simple. It's in the early stages of development. There are many more features that you could add on your own. This is only the start of your journey into Ruby on Rails development. As you continue, there are two important resources that can help you as you go along. The first is api.rubyonrails.org. The API pages are a good resource for finding out the details of classes and methods that are built into Ruby on Rails. For example, if you want to use a certain method, you want to know what arguments can be passed into it, or what options are available to you, the API is the place to go to. The second resource is guides.rubyonrails.org. The guides pages provide explanation of the different features that are available. So they'll tell you what's available and how to use them. You can use the guides pages to go deeper into all the topics that we've learned in this course, and there's also a number of other topics that you can learn about that are important for your web development. You can learn how to use shared layouts for your templates. You can work with assets such as images, style sheets, and JavaScripts. You can use validations to check that the data is acceptable before you submit it to the database. You can work with cookies and sessions to store data. Callbacks can go in your model to have automatic actions take place. You can use authentication to allow users to log in with secure passwords. And they'll also tell you about logging, sending and receiving email, and writing tests for your code. I hope that you will continue learning the many ways that Ruby on Rails can help you to build faster, better web applications. Until next time, happy coding.